Hey tech enthusiasts, welcome you all to pynetlabs CCNA Marathon. Get ready to dive into the world of networking excellence because we've got something special lined up just for you. Introducing you to our CCNA Marathon series designed to elevate your networking skills to new heights. This series is going to have 3 epic videos, each running for 6 to 7 hours, and will be available to you every Saturday. It's the ultimate learning experience you don't want to miss. In video 1, we'll cover the fundamentals, laying the groundwork for your networking journey. Video 2 delves deep into advanced concepts, while video 3 ties it all together with hands-on experience and lab scenarios. So let's start. The training has been organized for you guys by PyNet Labs, and now talking about myself, as I told you, my name is Abhijit Bakle, and you can call me AB. I'm gonna be the instructor for this training. And talking about myself, I've been delivering corporate training since last 8 years now, and as of now, I have my key expertise in routing and switching domain, in which is now enterprise network. Then I have my key experience in security domain, data center environment, and then I recently have been delivering a lot of trainings in network automation as well. So as you all are aware that there is a lot of boom in this network automation industry, we have kind of catered the same thing here, and we have been delivering network automation training since long time now, and that's the USP of PyNet Labs, where we are looking forward to cater the best training that is possible for you guys over there. So that's why we have came up with this very fundamental knowledge training, which we are going to cater the official curriculum of CCNA. And this particular training will involve theory, plus it will also involve labs during the training itself. So you're gonna get yourself introduced with the knowledge of theoretical, where we will start from the very scratch of networking, and then I will take this particular class further into all the concepts that are mentioned in the official curriculum of Cisco CCNA training. Right? If you face any difficulty during the training, you can directly put your messages, or if you can directly put your doubts into the chat session, or you can also put that into the Telegram handle as well, which has been shared with you. Otherwise, if you personally would like to get in touch with me, you can search on any of the social media platform, be it LinkedIn, be it Facebook, be it Instagram. You can just search for my name there, and I will just pop up there. Okay. So you can see that particular profile of mine over there. You can follow me over there and reach out to me. Otherwise, for any other queries or any other discussions that you would like to have, you can reach out to the Pasha as well, or Nitish as well. So these guys can actually help you to solve your queries or difficulties. So that's all I would say from my side, and I will basically move on to the conceptual knowledge of CCNA. So if we talk about CCNA, everybody is familiar that CCNA stands for Cisco Certified Network Associate, right? Cisco Certified Network Associate. And earlier, if we talk about the certification model of how Cisco used to deliver certification, then I would say that the certification used to be delivered in a way. There were 3 different type of certification. So I can say we had CCNA as the first level of certification. If we divide it into different level, then the second type of or second level of certification was CCNP, and the third level of certification was CCIE. And there were different tracks that were associated with these certifications. So I can say if we talk about tracks, then we had routing and switching as one of the track. We had security as one of the track. We have data center as one of the track there, right? Then we had different other tracks as well, be it collaboration, be it service provider, or be it cloud or anything else. So there were different tracks that are available into Cisco's official certification. And if we talk about, I would say, different levels, then you could do CCNA in routing and switching, you could do CCNA in security, you could do CCNA in data center, collaboration, and so on. And then once you become CCNA certified in specific domain, then you would go for your professional level certification. So if you're done with your CCNA in routing and switching, then you will go for CCNP in routing and switching, and then CCIE in routing and switching. That's how you actually clear all the links there, or clear all the certification levels there for a specific domain. And you can even go ahead and do the certification in multiple tracks as well. For example, if you become CCNA routing switching, you can also do CCNA routing, CCNA in security, or CCNA in data center. Or once you become CCNA and CCNP both in routing switching, you can do that for security as well. Or even all these tracks can be repeated for multiple domains as well. So when we say that this is a certification model which Cisco executed for almost now 30 years or 25 years. But on, you can say, February 24th, 2020, this is exactly when Cisco announced new line of certifications. Cisco made the biggest change in the history of their certification model. And now the CCNA that we look at, it is not associated with any of the tracks there. So we just have plain CCNA, okay, which stands for Cisco Certified Network Associate. And then you have two other certifications, that is CCNP and CCIE. And then the CCNP and CCIE are divided into different tracks. So the routing and switching that you actually used to see has now become something called enterprise. And then the other domains still continue to exist. So where you have security, where you have wireless, where you have data center, where you have service provider, where you have collaboration, and so many others. So now you cannot do CCNA for any specific type of domain there. Where you start get specialized with the type of domain that you have is from CCNP itself. So you can do CCNP in enterprise, CCNP in security, CCNP in wireless, and so on. Or you can also do CCIE in enterprise, CCIE security, CCIE in wireless, and so on. Makes sense? But you cannot do CCNA which is specifically binded towards any track or so. It is independent of any of the track that is available. And if we talk about how it works, so CCNA, again, it's an individual exam, which will be about like 2.5 hours of exam. And if you get 85% of score there, then you will basically be having your CCNA certification. And once you're done with your CCNA, then you can move on with the CCNP. Now, if I talk about CCNP there, then in CCNP as well, if we talk about old method, not the new method, then old method, for example, I want to pursue CCNP in routing and switching. Then there were 3 exams that were associated with this certification. First, you had to give the CCNP route exam. Then second, you will be pursuing the switch exam, CCNP switch. And third, you will be going for the T-shoot exam, troubleshooting exam. And if you pass all of these, then and then only you can actually become CCNP certified or CCNP routing and switching certified. And even though, like, if we consider the same type of scenario for other certifications as well, like CCNP in security or CCNP in data center also, this is how the thing was. So you need to give that particular like dedicated number of exams there. Like CCNP security had 4 different exams that needed to be passed in order to become CCNP security. But this is not the case now. So what Cisco have done, if you want to become CCNP in, for example, let's say enterprise. So in order to become CCNP enterprise, only 2 exams needs to be attempted. So the first exam in order to become CCNP enterprise will be the core exam, which is ENCOR. or NCore. And every module in the new line of certification has its core exam there. So if we talk about security, it has a core exam called Sec Core. If you talk about DC data center, then it has a DC core. If you talk about service provider, it has SP core. So every module or every track has their own independent core exams associated with it. Then the second exam will be called as concentrated exam. And this concentrated exam can be chosen from the list of different concentrated exams that are available. For example, the first option that you have is to take the advanced routing services exam, which we call it as NRC. Or if you can go up with uh, the design exam or the SD-WAN exam. So you have an option to choose an SD-WAN exam as well. You have an option to choose the design exam as well. Makes sense? You have an option to choose some other type of exam as well, be it like wireless implementation, okay, or wireless design. And there are different almost, there is also an option called an auto, which is for automating the enterprise network solutions. So all these exams are part of the concentrated exams. And what you need to do, you just need to pick any one of this exam, of these exams. So if you pass NCore, for example, and then if you pass NRC, you will become CCNP Enterprise Certified. Okay, if you pass NCore and N-Auto, you will become CCNP Enterprise. You will pass NCore and SD-WAN, you will become CCNP Enterprise. Just like that, what you need to do, you need to pass a core exam and you also need to pass one of the concentrated exam that is available there. Makes sense? So just like that, the same thing is available for every other type of module there. So where in security you can do that. Yeah, you can, if you want to do security, then you can actually do that core exam of security and concentrated exams of security as well. Make sense? So when we think about that in that way, then how it works is you don't need to be CCNA certified in order to become CCNP certified, but individually you can actually go ahead for the CCNA certification first. Okay, consider this as the first step if you're starting your career with networking, and then go for the CCNP enterprise certification. Okay, these two certifications are the most recommended certifications from my side, I would say, because these two certifications clears most of the fundamental knowledge of what you actually need in order to get a job, in order to step up in your career, or in order to understand networking in a deep manner. Make sense? So CCNP can your guiding hand there, and then after that you can actually move ahead with CCNP certification. You get that? So now as you're familiar with this CCNP certification, then there is a new line of certification that has actually came out. Because if you talk about different streams that are available, then you have routing and switching, which is now enterprise. Then you have security, then you have data center, then you have service provider, then you have different other certification. But there is a new line of certification that they have announced, which is called as DevNet certifications. Yeah, CCNP Cloud is not there in the new exams. It was there in the old exams that you could do CCNA in cloud, CCNP in cloud, but they have completely removed this cloud examination from there. And those who had cloud examinations or those who had cloud certifications, they have got offered the equivalent data center examination or data center certification. So they have merged with data center and cloud is no longer available there. So if you want to, yeah, someone is asking if you want to develop a career in security, then I would recommend, or if you want anyone to go in a specialized track, be it like anything apart from enterprise, be it security, be it service provider, or be it something else, then I would recommend you to first finish your CCNA and CCNP enterprise, and then go for CCNP security. So whatsoever specialized track that you want to become, then you can actually go for the enterprise certification first and then jump into the specialized certification. That's how you can go ahead. Cool. So Cisco have came up with the latest certification, which is DevNet. And this DevNet is more of something called network automation. And what this network automation is, it means that in with the larger complexity of how network is actually growing in today's world, there is a need in order to, I would say, cater the need in a way that you should be able to configure, manage, and troubleshoot all the devices of your enterprise network with a centralized location. For example, you don't need to configure each and every device every time there is a problem, or you don't need to go onto each and every device physically and configure the same. You should be able to automatically deploy the configurations, or the devices should be able to automatically resolve the problems that they have. So this DevNet track actually focuses on the same thing, on how you can actually implement network automation inside your network. Makes sense? And the certifications that are followed there is DevNet Associate, which is just equivalent to CCNA, but the content is different. And then there is CCDP as well, DevNet Professional. This DevNet Professional, however, covers the same type of blueprint where you have a core exam, which is called as Dev Core, and you have the other type of exam, which is called as concentrated exams. And these concentrated exams are nothing but the automation module that you will find in the concentration exam of every other track as well. So if you consider about enterprise, then there is an automation track called an auto. Then if you consider security, then there is sec auto. Then there is DC auto, right? There is some other type of exams as well. And every automation module is present at the concentration exam of the DevNet itself. So if you do dev core and if you do n auto, okay, then you become CCNP certified as well if you already have n core certifications. And then you again become DevNet professional as well, and enterprise professional as well, by just giving 3 exams. So you can give the first exam can be for N core, the second exam can be for dev core, and the third exam can be an auto. When you give all these 3 exams, you become CCNP in enterprise, and you become CCDP in DevNet. Make sense? That's exactly how the new line of certifications are working out here. And I hope you understand that how it actually works. So talking about these line of certifications, what we are going to do is we will make ourselves comfortable with the content of CCNA, and then we will start learning CCNA line by line. So let me just put my thing on charge, and so I hope you can see me now and you can see my display over here. Okay. So the first section will be introduction to network fundamentals, and then after that, after getting familiar with that, we'll be moving on with the second thing that will actually give you the things about IP addressing and subnetting. So we'll be spending a lot of time on getting to know about IP addressing, and we'll be spending a lot of time on subnetting as well, because this is key concepts that you actually need to be familiar with. And once you get familiar here, then we'll be moving on with getting to know about how to use networking devices. Okay, so I'll be giving you an introduction to what all are the devices that are available, be it routers, be it switches, okay, be it firewalls, be it load balancers, be it IDS, IPS security devices, and many others as well. So we'll be spending some time in order to get to know about what all these network devices does, and then we'll be implementing like configuring the network devices. So we'll be spending some time on getting to know how you can configure the network devices with Cisco Internetworking Operating System. I'll make you familiar about how you can actually use Cisco's Internetworking Operating System in order to configure something. And then we'll move on layer 2 services. So we'll get to know about different topics like VLANs, we'll get to know about how VTP works, we'll get to know about how trunking works. Okay, then we'll talk about how actually you can say HSRP or spanning tree protocol works, and various other layer 2 technologies. So we'll be talking about all those technologies there. And then we'll be spending some time on layer 3 services, where we'll be talking about different routing protocols. So be it routing information protocol, be it static routing, or be it dynamic routing in a way that we will get to know about EIGRP, OSPF, okay, and various others as well. But we'll be spending the lab, or we'll be doing the labs for each of this protocol that is available. And then we will be jumping off into security section, in which we will talk about access control list, in which we will talk about iOS security. And this iOS is not Apple's operating system. So it's, I would say, Internet Web Operating System security. Okay, and then we'll be spending some time on, you can say, IP services, where we'll talk about uh, network address translation, and we will see how IPv6 is changing the game. And once we get familiar with all of this, then we will look at some of the security concepts even more. I'll give you an introduction to how DHCP concepts like DHCP snooping works, and how dynamic ARP inspection works, okay, and how port security works. And I'll give you an intro to VPN as well, virtual private network. And then the next section will actually focus on WAN technologies. And the last section will be focusing on automation. So we'll get a glimpse on how automation is actually done on different devices there. And these are going to be the pointers that will actually help you understand the flow of the class, and it will make you comfortable with what the content is going to be covered in this training entirely. Make sense? Great. Yes, CCNP is still an intro level certification. All right. So as today we are going to discuss entirely about introduction to network fundamentals, and we will talk about what is a network, why do we actually need a network to be implemented in our production environment, and we will see how do we make like networks, small networks, by combining multiple devices together by using some of the services like IP addresses and so on. So, and then we will see how OSI and TCP IP model comes into picture. So to start the thing with a pretty exciting session, I hope you all are energized for this session. And here we go. Introduction to network or computer networks, whatever you say. So what is a network? Whenever you consider something in order to understand what actually is a network, then you, I would say, consider that this is one PC, and then you have another PC here. Now, if both of these PC wants to communicate together, how do they do that? They can actually send some traffic that, let's say this is a boyfriend and this is a girlfriend, and then BF and GF talk with each other in a way that, hey, sweetie, how are you doing? Okay, and this is a message that the boyfriend wants to send to the girlfriend by using one of the messaging application, let's say WhatsApp. Now, what are these? What are the requirements that you actually need to complete in order to fulfill that the message gets delivered to the girl? One of the requirement is the IP address should be configured onto the device. Then WhatsApp should be installed onto the device. The third requirement is internet should be on. Internet must be on there, right? And fourth, they must be in relationship. Otherwise, there's no point in sending the message, right? I hope you get the feelings. So when you actually want to send a traffic, that traffic contains a lot of feelings there and a lot of IP packets as well. So we can consider that the feelings will only get delivered only if it satisfies the conditions of IP addressing, only if it satisfies the conditions of networking and how the network should work. So you can say that the communication can work in multiple ways. The communication can actually work in a wired way or in a wireless way. Your feeling has the power to travel with wire as well and without wire as well. So if we go according to the wired communication, then you use different devices, or you can say you use different, I would say, communication standards in order to connect one PC with the other PC, right? And when you use those computers or mobile phones also, because most of the mobile communication happens wirelessly, where you can have a scenario like this is a mobile PC, and that particular or that mobile computer is connected with Wi-Fi, and that particular Wi-Fi might be situated inside your home. So this is your home, and that's your router, and your router is actually connected with another router, which is of ISP router, and the ISP can be anything. It can be something like we have very popular ISPs in India like Jio or Airtel or Vodafone or some others as well. In United States, or if you talk about some international ISPs, we have Verizon, we have Sprint, we have AT&T and others as well. So what do? You actually purchase an internet pack, or you actually purchase a broadband connection in your house, and then the ISP kind of gives you a cable inside your house, and that cable can actually be um, STP cable, shielded twisted pair cable. Okay, we'll be talking about different cable characteristics as well. But when that cable is given to you, this cable can actually either be two type of connections. You can have a copper connection there, or you can have a fiber connection, because there are most of the ISPs in the metro cities who actually gives the broadband connectivity over the fiber as well, to which we call it as FTTH, fiber to the home, right? So when you install this broadband connection within your house, then your router starts giving signals, be it wirelessly, or there can be a computer which is connected with the local area network as well by using wired connectivity like that. So there are different devices which are actually connected by Wi-Fi, and there are different devices which are actually using the LAN service, or they are connected by using the physical ports. So the router that you actually have in your house has a WAN port, okay? And in that WAN port, you will actually install the cable that is coming from the ISP end. And then after that, when you configure your LAN ports with the devices that you want to create connectivity with, you can also configure your wireless settings so that your router starts sending wireless signals to the devices that want to get connected, that wants to get connected with the router with wireless. Now, this ISP that we're talking about, let me just drag this topology somewhere down here. Yeah. So when we talk about this ISP, then this ISP might be or must be connected with some other devices as well. For example, this ISP is connected onto a WAN network, wide area network. And this WAN network is again connected to some other ISP, or let's say ISP2. And with that ISP, this is the house of your queen or princess or whosoever you're dating. And then there she is. She is connected with another router in her house. And then she is also using wireless communication to get signals from the router. But this router again is connected with the ISP2. And then you might have some physical machines connected with that router as well. So you can consider it somewhere that this is site A and this is site B. And the relationship that you're dreaming of can only be achieved if both of the sides are connected to the internet, I must say. So when we assume that you are sending some traffic from one PC to other PC, the logical scenario in our mind can be like this, that you have the direct connectivity and you are able to send traffic directly from one PC to other PC. This is what we assume, that if we open up our mobile phones, we open up any chatting application or social application, and then we type our message, and then we send it to the destination, and it gets delivered. So this is how the picture is that you assume that. But this is not how it works, because there are lot of devices that are in between. Whenever you're trying to communicate with some or the other way, then there are many entities that are actually connected with the device there. So this is how you communicate. You first will be reaching out to the router. Then the router will take you to the ISP, which is its gateway. And then you will be able to reach out on the entire internet, and the internet will route your traffic to the other ISP. And it is also possible that your girlfriend or your whosoever you are communicating with, that particular person is also connected to the same ISP. So whatsoever requirement is there, then the ISP reaches out, or the traffic reaches out to the ISP, and the ISP forwards that traffic to the destination. And everything happens in a way or in a specific way. And there is a lot and lot that goes into your packet. It is not only your feelings that are constructed in a way or in a message or so. There is a lot of other things as well which goes around the network with your message. Make sense? And what are those things? Yeah. So when we consider that you actually want to communicate with the devices there, we assume that this is how the communication works. The traffic goes from here, all the way here, all the way here, and then it gets delivered onto this device. Makes sense? But there is a lot of process that has involved or that is involved in it. And we call something as a computer network in a way, like in a standard definition, that whenever there are two or more devices that are connected together and they have been configured with the IP addresses, then we call it as a network. Assume that if we have a classroom, and in that classroom there are multiple people who are actually sitting. So you can say that this is a classroom, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 people actually are sitting in that classroom. So we can call it a network of people or network of students. Just like that, instead of having these, I would say, people, you can have or you can assume that these are not people, these are actually computers. And just like that, you have multiple computers in a room. And when you connect all these computers together, then you call it as a computer network. Make sense? And this was kind of an old technology, or I would say this was kind of an old terminology where it was assumed that a network can only be created whenever the network is actually made up of computers. But nowadays, there are so many other devices. You can use your smartphones, right? You can use your laptops, you can use your iPads, you can use your tablets, you can use your home appliances. Okay, you can use IoT devices, and you can use almost every appliance that you use, be it watches, be it even now they're like wireless headphones, gaming laptops, and so many other things that can actually be connected into the network or into the computer network itself. So it doesn't need to be any specific device that actually can communicate with the network, because in the earlier age it was only computers who had this superpower of getting connected with the network. But then with the evolution of the IT technology, you have almost every device now that can actually be connected to the internet, be it TV, be it television, be it your refrigerator, be it any home appliance, be it any I would say office appliance, be it any personal appliance, everything, almost everything can be connected onto the internet. But there is this way. Why do we actually use this internet? In order to exchange the information from one device to another device, or from one PC to another PC, or from one mobile to another PC, or any combination of devices. Make sense? So how does it actually work? Everything comes in a play when you actually think of it in a way that how networks were when they were actually created in the early age of internet, for example 1980s. Okay, if you think of network, that how it was in the early age of internet, then you can assume that there were different devices that were actually needed to be connected together. For example, there was a university, and it was a university project where lot of people a lot of people were using different resources. So for example, this is a university, and the university had 20 computers, and all of these computers was was being utilized for the research purposes. So as they were being used for the research purposes, then they need to do some sort of other operations as well with the research that they're doing. For example, these 20 computers needs to print around I can say 20 pages per day of their research that they do. But the limitation was the university only had two printers. Okay, and you can say the two printers were divided was one at each building. So the scenario was that sometimes some of the people would sit into a building and they could only use the printer that is available inside that building. But they could not use the printer that is available in some other building, because they would have to walk off from that building and then get into the other building and then reach out to the computer or the printer and then do their printing that they have to do. So this was one of the resource problem that was being faced. Now, what they did then, they initiated something that by using the network interface card, they could actually communicate with multiple or with the resources with the help of a network. And what they did, they kind of used this particular, or they kind of used each and every computer that they had, be it whatever, and they connected it with a centralized device which was called as a hub. So hub was a device which would actually connect each and every device together, okay, and be it like printer as well. So you had two printers there. These two printers can actually be connected onto the network. And then nobody would have to walk off to the to the printer physically, and then they will not be needed to print it out by themselves. What they can do, they can actually connect that particular printer onto the network, and then they can like give the instruction to the computer that printed, and by with the help of the printer being connected onto the network, they could actually print that particular paper from remote. And it was possible to also access the printer that was situated into second building as one of the resource that can be made available to the people into the first building. You get that with the help of a network. Just like that, when network started to grow, then there were four different campuses that were actually being connected with the network. So this was campus 2, then you had a campus 3, and then you had a campus 4. Make sense? So when you have this particular campus there, you could actually connect each and every campus together in this fashion. And then there were different research people that were sitting at different campuses, and they could actually exchange the information that they are working on. Do you understand that? With the help of a network itself. But now, here comes the major problem. In early days of internet, The solution or the most famous company that was actually selling the computer applications or computer systems was IBM, right? And IBM was a company which was actually selling most of the computers back then. But it was not like a thing that other companies were also not popular, because there were companies which existed like Dell, and Apple was also coming up back at that time. And people were actually looking forward to purchase devices made by the other companies as well. Now, what the problem was that if you want to put a computer in a network, then you would only be able to communicate with the computer of the same vendor. That was one of the requirement, or that was one of the limitation there. Because back then, the computers that were actually made by IBM were using a solution which was called as DECnet. And network interface cards which were manufactured by IBM computer could only, I would say, communicate with the computers or with the network interface cards that were manufactured by IBM itself. You get that? So which means that if you have a computer which is of IBM, let's say this is the computer that is IBM made, and then this is another computer which is manufactured by Dell, then you guys cannot actually communicate in a network, no matter like if your computer is fully capable of getting connected onto the network. Makes sense? This is not possible. So how do you solve it? Then, as the requirement was kind of getting grown, and as organizations or standard bodies kind of realized that in order to make this network a bigger one, you actually need to have a standard, you can say, protocol suite, because there were different transactions that were being carried into the network. So transactions like using different protocols. The protocols were like HTTP protocols, the protocol were FTP protocols, be it the protocols of Telnet, okay, or be it SNMP, or be it some other type of protocols as well. So when you have all these different protocols, these different protocols were installed into directly into the NIC, network interface card itself. Makes sense? So when you have this network interface card that can only be able to understand the protocol which is manufactured by one vendor. For example, if you have an IBM machine and if you have Dell machine, both of them are capable of like executing an FTP transaction. But the FTP that IBM understands is different than the FTP that Dell understands. Both of them were kind of different protocols there. Make sense? And just for the same requirement, when the, I would say, researchers or when organizations kind of identified it, then they announced something that these type of communication should be made standardized, or whatever protocol you actually use, this protocol needs to be made standard step. And that's exactly when OSI model, or that's exactly when open system interconnection model came up, or which we call today as OSI reference model. And with the help of this OSI reference model, what happened in OSI, there were different, I would say, layers. So OSI model brought a concept to which we called as the layered approach. You understand that? And in this layered approach, there were different layers. So the layers that were involved was application layer, a presentation layer, then you had a session layer, a transport layer, a network layer, then a data link layer, and a physical layer. You get that? So you can have multiple layers over there. And every protocol that is out there will actually be a part of some or the other layer over here. So if you say protocols like DHCP, protocol like DNS, protocol like HTTP, were all kind of becoming part of the application layer. Where at network layer there was a very famous protocol called IP that used to work. At transport layer there was a protocol called TCP or protocol called UDP that was actually working. Make sense? At presentation layer, there were different job responsibilities that was given to presentation and session and data link and physical layer. So every other layer was actually, so all the layers that you have in today's world, every layer that is available there is actually part of this OSI reference model. However, this reference model is not something that we usually use in today's computer environment, but this is something that is referred in order to understand how it actually works. So what we are going to do here is we are going to get ourselves introduced with each and every layer that is available. And there is something which is called as encapsulation and decapsulation. And we'll be getting to know about what this encapsulation and decapsulation does. And then we will be understanding the fundamentals of OSI model and compare it with the new model that competed with the OSI model, which is now called as TCP/IP logical model. And that's exactly the model that we actually use in today's world. So let's get ourselves introduced with what this particular model does. Now, do you remember I gave you an example that a boyfriend is looking forward to communicate with the girlfriend, right? So, when a message is sent from one end to the other end, then there is a process that is followed. And that particular process is called as encapsulation and decapsulation. So how does this encapsulation and decapsulation work? We're going to get ourselves introduced with that, with the same thing. So for the same thing, what you need to do, you need to understand each and every layer that you have here. And when you understand what each and every layer does here, then you would be pretty familiar with what and how the communication is actually done between the devices. So let's get started. As I told you that whenever the machine or whatever machine that you're working on tries to communicate with some or the other device that is available, then before leaving your computer, for example, that's the computer that you have, and then you are actually look connected to a router, and that router is connected to the ISP network. And then there is some resource onto the internet that you want to access. Let's say youtube.com, and this is where the YouTube server is. So the communication will of course be in this way. But when your actually request or when the request starts to leave from your computer and reach out to the gateway, it collects some of the information from your computer. And what that information is? That information will be according to the application layer that is available. And an application, so the information or the encapsulation is done from the top down approach. So first it will collect information about application, then it will come down to presentation, then it will come down to session and transport and network and so on. And once it reaches out to physical, then your data is actually sent onto the cable. Otherwise it just stays there in your computer and collects some of the information that is pretty prerequisites for initiating that communication. So when we say this, then at application layer, which is the layer number 7, we call it, because layer number 1 is physical, then 2 is data link, the 3 is network, 4 is transport, 5 is session, 6 is presentation, and the 7th one is application. So when we actually look at getting the data uh, ready for sending it over there, then the encapsulation starts at the application layer. And at application layer, it collects information about the resources, whether available or not. You get that? Meaning that, so see, can you use WhatsApp if you don't have the WhatsApp application downloaded in your phone? Or can you use Facebook? Or can you use Twitter? Or can you use YouTube or any other application if that's there? Can you access that particular application if the application is not installed in your machine? Would you be able to do that? You cannot do that, right? And why you can't do that? Because application is like the most important thing that you need to have if you want to, I would say, if you want to communicate with whatever thing needs to be done there. And how do you do that? So you go to the Play Store, you go to the App Store, or you whatever wherever you will be able to download the application, and then you will see the information that you want to actually access. So just like that, if you want to reach out to the server of YouTube over here by making this type of travel, then your device needs to make sure that what is the resource that you're using, because that's the information that the YouTube will actually need to understand. So the device collects information from your machine at application layer, that whether enough resources are available or not. And if enough resources are available at the application layer, then it collects that information and moves out to the presentation layer. And when it moves out to the presentation layer, then at presentation layer, it does something in a way that there are some responsibilities that presentation layer handles, and those responsibilities are called as the process of compression and decompression. Compression and decompression is something that is taken care by the presentation layer. Meaning that after getting to know that you have enough resources that are available at the application layer, then it will come down to presentation layer. And then at presentation layer, there can be multiple type of data that you actually want to access. And that data can be of a type that it is kind of an MP4 video, or it is kind of JPG or GIF image, or JPEG image, or MKV video, or any other type of data. It can be a Word file as well, it can be an Excel file as well, or it can be a PDF file as well, or so on. So there are different file types that are available with each and every file that you have. And if you are looking forward to use one of that particular file, the presentation layer is responsible for figuring out what type of file actually you use, or what type of file that you need to format it into, or do the compression over there. And how do you do that? You basically type that particular, or your device will collect the information, and your device will specify that, okay, this is the format that the data can be visible. So when you access the resources of YouTube, there is something like MP4 video, or there is some other type of data that you are accessing over the internet. And presentation layer is responsible for taking decisions on how to represent the data to the user. Makes sense? That's something that presentation layer takes care of. And then you look into something that how session layer can actually be responsible for. So when it comes down to session layer, then session layer is responsible for keeping, you can say, responsible for keeping separate application data apart from each other. You get that? So session layer is kind of responsible for keeping different application data separate from each other, or separate application data different from each other. Well, you can call it however you want. So when we consider these things, then you actually, I would say, need to make it familiar that, for example, let's say that you have a web application. Now, if I consider that this is your web browser, let's say, and then this web browser is using different tabs there. So the first tab is YouTube, the second tab is Facebook, the third tab is Insta, and the fourth tab is LinkedIn. Okay, these are four different tabs that you have in your web browser. Now, let's assume that the device is using an IP address of 192.168.1.5, for example. And then all these different, I would say, servers that you're accessing, or all these different websites that you're accessing, will be having independent server, correct? So let's say that the server of YouTube is available at 11.1.1.1, considering like random IP addresses. Then the Facebook server is available at 22.1.1.1. Then the Insta server is available at 33.1.1.1, and LinkedIn, or the server of LinkedIn, is available at 44.1.1.1. Makes sense? This is how the information is available to you guys. So when you consider that this is how the information is, then can I say that when you are actually communicating from your PC to the YouTube, then the source IP address for this is 1.5, and the destination IP address will be 11.1. Do you understand that? Just like that, when you will communicate with Facebook server, the source, however, will be the same, 1.5, and destination will change to 22. With LinkedIn or with Instagram, the source IP is again going to be same, and the destination will be 33. And with LinkedIn, the source IP address will be the source IP address will be 1.5, and the destination again will be 44. So as we were discussing about session layer, you can say that the source IP is always going to be same, and destination IP address will be different for that, right? Now tell me one thing, that whenever these servers are going to solve your query and give you the reply back, because you will be sending the request to each and every server here, and then they will be giving you the reply back. And when you do that, then you actually do it in a way that your source will be same while you send the query, the destination will be different. But in the opposite way, whenever you will be like getting the reply back, then it is going to be the destination IP, the source IP address, that is going to be different, and then the destination IP will be same, that will be of your PC. So as the different servers are sending the data onto the same IP address, right? Have you ever seen that your YouTube application data opened up into Facebook tab, or Facebook's data opened up in some other tab, right? Like Instagram tab, or Instagram data opened up in LinkedIn or so? Have you ever noticed that? Exactly. You won't see that ever, correct? Why so? Because session layer is responsible for keeping different application data separate from each other. Okay, and that's what it does over there. Now all this data, because if we look at I would say these different layers that you have here, then all this data into divided, or the OSI layer itself is divided into different aspects. So when we say that this aspect is called as, or the terminology for that is PDU, and PDU stands for protocol data unit. Okay, so when we collect information about your application, presentation, and session, then the PDU fills up the data, or considers that data as raw data. It doesn't give any of the information, or it doesn't give any name to that data, because when we consider application, presentation, and session, then these three layers are called as software layers, which contains, or which actually collects information from your machine about the applications that you're using. Then if we consider network, data link, and physical, then all these three layers are called as hardware layers. And this transport layer is called as heart of OSI. Make sense? So when your computer actually collects the data from application, presentation, and session layers, this data will be considered as raw data. And then once the session layer information is collected, then you actually come down to the transport layer. And then inside the transport layer, when you come down there, then the transport layer will convert the PDU into segment. And at transport layer, the task of identifying whether TCP needs to be used or UDP needs to be used is done. So identification of TCP and UDP is done at transport layer. Make sense to you? So when we say now let's consider what is the difference between TCP and what's the difference between UDP. Some of you might have heard that TCP is reliable and UDP is not, or so or so. So TCP stands for transmission control protocol, and UDP stands for user datagram protocol. Correct? TCP stands for transmission control protocol and UDP stands for user datagram protocol. And what are the differences between TCP and UDP? It is treated that TCP is connection oriented, and I'll tell you the reason for that. And UDP is connection less, right? TCP is reliable and UDP is not reliable at all. TCP is slower and UDP is faster. Then there are other characteristics as well, that delivery is provided into TCP, while in UDP there is no guarantee of data delivery also. And if we consider the most important factor, then TCP is used for latency sensitive, or you can say TCP used for something, you can say delivery sensitive data. And UDP is used for latency sensitive data. Make sense? And how does it actually works? So it all works with the help of a concept which we call as three-way handshake protocol. Yeah, UDP works in real time as well. But TCP also works in real time. That's none of the thing over there. So it all works with the help of three-way handshake protocol. Okay, now let me tell you what three-way handshake protocol is actually. Let's say, for example, that you want to communicate. You are sitting over here, and this is A, and then you are sitting here and got B. And for example, say that in a classroom, you're sitting, I'll give you a small short story. So in a classroom, you are basically sitting there with one of your friend, okay? And then that particular friend of yours wants to wake you up or wants to communicate with you, okay? Because let's say A has his girlfriend waiting outside the class, but B is sitting with him and B wants to tell him that, hey, A, your girlfriend is outside waiting for you. But as A is sleeping, he cannot really listen to any of the informative thing or beneficial thing that B is saying. So how would it ensure that? So how it works is A wants to communicate with B. So what will B do? B first initiates something called synchronized message. And what this synchronization message would be, B will try to wake him up. Hey, A, wake up. There's something for you. And when A wakes up, then A gives the acknowledgement to the synchronization that, hey, B, tell me what is it. And then it will also send its synchronization message that, yes, I have waken up now, I can listen to your messages. And then B gives the final acknowledgement. Make sense? That is how it is associated, or let's say when that is how A and B will be able to communicate. So when B gets ensured that A is no longer sleeping, then B will give the final message to him. Just like WhatsApp. Imagine you open up the application and you open up a contact of yours. So when you open up that contact, within 1 or 2 seconds, you start to see whether the user is online or not. Correct? Now during that 1 or 2 seconds, until you see that the participant or recipient of the message is online or not, be it your girlfriend, be it your boyfriend, or whosoever, till then your device actually figures out like with the working of three-way handshake protocol, and it exchanges some of the messages there. And once it gets assured that the recipient party is online, then the device starts to show you that the user is online. Otherwise, the device will print you the last seen data or the last seen time if it is visible or not. So that is how three-way handshake protocol actually works. Before actually sending a data, it actually initiates or it actually establishes a TCP connection with the destination. And once the TCP connection is established, then and then only the communication will be started there. Makes sense? And that's why we say that TCP is connection oriented protocol and UDP is connectionless, because in UDP there is no such case that happens. That the data will directly be sent and there won't be, I would say, anything that will actually, yeah, there won't be any connection oriented thing or three-way handshake protocol that will be exchanging some of the messages. And as this three-way handshake protocol ensures that the data will get delivered, that's why it is reliable, and UDP is not reliable. And it is slower and faster, and delivery is guaranteed, and there is no delivery guaranteed. Okay, why so? Because if using TCP, it also gives you an ability to use error correction, or there are some other things that are followed into TCP. So when we consider those things, TCP actually uses something called windowing, okay, or something called segmentation, or something called error checking or error correction. And how that? Let's say if you have a message, yeah, SIP actually works there. So let's say that there is a message. Message is, hello, how are you? This is basically a message that A wants to send to B. Makes sense? Now, when this message needs to be sent, actually, depending on the size of the bandwidth, depending on the size of the traffic that can be shared or so, the message will be segmented into different chunks of data. And all these chunks of data will be numbered. For example, random number 101, 102, 103, 104, 105, and like that. Now, when windowing gets done, windowing is a process of figuring out the maximum size of the window that the chunk of data can go. If you have like ever noticed that whenever you initiate a file transfer thing in a Windows machine, then the file transfer utility actually shows that at the initiation it will take 2 hours of time to complete the file transfer. Then on the next instance it shows 1 hour. The next instance to that it will show 30 minutes, and then 15 minutes or so or so or so, and the size gets divided, and after some time you start to like get the real value that okay, it's gonna take 1 minute and 30 seconds, then 29, 28, 24, like that. Correct? Now till the time it shows real data, till then the device is actually struggling to figure out that what is the size of the window, how much of data can I send so that it doesn't cross the limit of the receiver. So earlier it sends two, like 10 packets, for example. If they will get successful, then it sends 20, and then 40, and then 80, and so and so. It starts increasing the size of the packet or the size of the packets. Okay, and where it detects failure, then it goes on to the last successful size, and then it keeps on sending the data according to that. That's what is called as windowing. Now this windowing also follows something called segmentation and sequencing. So as the data will be segmented into different chunks, for example, your window size is 2. So at the initiation, A will send packet number 101, and the packet number 102 will be sent. Okay, and when those packets will be sent, then the receiver actually needs to acknowledge back with the next value or with the next packet. And then it says, okay, I have received 101 and 102, send me 103 now. Then the sender will send 103 and 104, and then the receiver will acknowledge with the next value, which is 105. Makes sense? That is how the sequencing and segmentation actually works. If the device doesn't receive packet number 103 or packet number 102, then what happens? Then at that particular time, the acknowledgement will be sent for 102. And then the device kind of recognize, okay, the packet, the actually the destination received packet number 101, but it didn't receive packet number 102. So it will restructure the next data to 102 again and 103. And then if the destination receives that data, then it will acknowledge with 104 as the next packet or so. And that is how the thing is actually done. Do you understand that? Please acknowledge in the chat. Perfect. So that is exactly how TCP and UDP works over here. And when we say that the transport layer, then transport layer actually does the work of detecting or identifying that whether it should use TCP or whether it should use UDP for the current like communication that needs to be done. And still your data or your device has not initiated the transfer of that particular traffic in order to reach out to that YouTube server. Make sense? So when we specify the transport information, then it comes down to the network layer. And then network layer transfers or converts this segment into packet. And then it adds the information about source IP address, and it adds the information about destination IP address. Okay, and then it also contains the data that is being coming up from the upper layer like TCP and UDP, plus it will contain the data as well, and that's what packet content will be. Do you understand that? And as you know that the devices which actually works with at network layer are routers, because the devices that works with IP addresses are routers, and that's why we call routers as layer 3 devices. Makes sense? And once it collects the information about network layer, then it will come down at data link layer, and the packet will then convert from packet to something called frame. And the frame will have content of source MAC address, plus it will add the content of destination MAC address, plus it will have the content of source IP and every other information that is coming from the upper layers, plus TCP or UDP, plus it will contain data. And that's what the content of frame actually will be. Do you understand that? And then at the physical layer, the frame will be converted into signals, or it will be converted into electronic signals, or I would say binary data. And then the data is actually sent onto the cable, and then it reaches out to the server or to the destination by following the routing or following the every other method that it needs to follow. Make sense? So this process that we actually discussed is called something as encapsulation. You get that? And whenever the destination device actually receives the information, then it will does the exact opposite process of something called decapsulation. So it will open up the physical layer, then it will go to the data link, and then it will go to network and transport and session, build up session, figure out how the data should be represented, and then it reaches out to application. And once it reaches out to application, then the data will actually be shown onto your window. So that is how encapsulation and decapsulation is done in OSI model. You understand that? So when we say that OSI reference model is actually something that can be used for reference purposes, but this is not something that is used in our devices, because OSI model came into existence, or when we talk about it, then OSI model actually came into existence in 1984 by an organization called ISO, International Organization for Standardization. And just like that, there was some other model called TCP/IP, which was again brought up in around same year, I would say, but in around late 1970s or early 1980s or so. And that was developed by Department of Defense. And this Department of Defense model, where OSI model consisted different layers, right? 7 layers, which was, if we consider OSI, then OSI had presentation, session, then it had transport, it had network, it had data link, and it had physical, right? But the TCP/IP model only consisted of 4 layers, and those layers were application, those layers were transport, okay, then it was network and physical. So the first 3 layers, application, presentation, and session, were equivalent to the application layer of the TCP/IP model. And then transport layer was same as of transport layer, and then network layer again was same as of network layer, and data link and physical was made to physical layer of the TCP/IP. So it still does the functionality of all the 7 layers, but I would say the layers are shrinked down to only 4 layers. Makes sense? And in today's world, the model that we actually use is a TCP/IP model. So we call TCP/IP as logical model because that is something that is used in today's world. And we call OSI model as a reference model, which means we can refer to this model in order to actually understand how the process works of encapsulation and decapsulation. Do you understand this thing? So I hope now it is clear for you how the communication over the internet or how the communication over the network is done. Now you have understood how we actually uh, encapsulation, decapsulation thing works. But none of it is possible, or none of the thing is possible if we don't use IP addresses in our network, right? So there are, I would say, a different type of communication that we actually work around with, and the type of communication that we have. One, you have unicast. Then second, you have multicast. And third, you have broadcast. Right? Unicast, multicast, and broadcast. These are the 3 type of communication that you have, or the communication mediums that you have. Makes sense. So when we say unicast, unicast refers to more of one-to-one communication, right? Which means like one PC or one system can communicate with the other system. Then if we talk about multicast, then multicast is one to many communication, like in a group or so. And then if we talk about the third type, which is called as broadcast, then broadcast is called as one to all type of communication. You get that these are different type of communication, but these communications are only possible whenever we say, whenever we consider something like subnet or like IP addressing and all needs to be used. Okay, if your system doesn't have any IP addresses, you cannot really make use of that particular communication. Now, if we say that, as I told you, that the communication is only possible when IP addresses are communicated or IP addresses are configured on your systems. Good. So, in order to see or in order to be able to figure out that how IP addresses works, then if we talk about IP addressing, then we have been using IP addressing for long, and without IP addresses, no communication will be done. So this is how an IP address looks like, right? 192.168 dot, let's say 32.46. If you look at this IP address, this is a 32-bit IP version 4, okay? And it is in the form of dotted decimal form. Makes sense? It's in the form of dotted decimal. So when you see that, then the IP address can again be divided into four parts, and each part can be called as something called octet. You get that? An octet is made up of 8 bits. Cool. So octet is made up of 8 bits there. And the IP address again is, I would say, segmented into different, I can say, classes. So there are different classes, and I can say the ranges are also divided accordingly. Ranges of IP address. So I'd say we have class A, we have class B, we have class C, we have class D, and we have class E. Okay. So class A has a range of 0 to 127. Class B has a range of 128 to 191. Class C has a range of 192 to 223. Class D has a range of 224 to 239. And Class E has a range of 240 to 255. You get that? Dotted decimal means that the structure of the IP address is in a way 192.168.10.1. So the values that we are using are decimal values in each octet, right? 0 to 9. And you can see that the screen or the structure or the octets are divided with the help of dot. That's why we call it as a dotted decimal. The values are decimal and the structure is dotted. Cool. So as I told you that this IP address structure is divided across different ranges and different classes of IPs. We have class A, class B, class C, class D, and class E. However, we only use class A, class B, and class C. Only these three classes are publicly available. Class D is reserved for media and multicast use. And Class E is reserved for future and military purposes. Make sense? This is how the classification is done for different classes that you have available. And in order to identify that what is the class of the given IP address, you just need to compare the first octet with the ranges here. So if the first octet of your IP address is 192, then you just need to check where does 192 fit in. And as you can see, 192 fit in this. That's why it will be called as class C IP address. Makes sense? This is how it is assumed. If your IP address is something called 72.11.23.71, then what will be the IP address? What will be the class of the IP address? It will be class A. Makes sense because 72 comes into the range of 0 to 127. Just like that, if you have an IP address called 172.16.0.1, then this will be class B IP address. So this is how classification of IP address is actually done. So whenever the manufacturers actually came with the ranges, then it was actually standardized that you cannot actually use class D and class C. So there is no information that I can actually give you regarding those. But yeah, I would say that the ranges are, I would say, reserved, and the information regarding that is not disclosed that much. So you can consider that we will be only discussing about class A, B, and class C. Now, in order to understand the IP addressing in a much better fashion, what you need to do is you need to learn how to convert the IP address into binary. So something we call as binary conversion. Cool. And this binary conversion needs to be learned here. So when we say how binary conversion can actually be learned, let's consider an IP address 192.168.32.40, because binary is what our computer understands. A computer doesn't understand anything in decimal also. So when you enter an IP address, it actually converts that IP first into binary, and then like uses that IP for the communication purposes. Make sense? So like this, what we are going to do is we will take each and every octet separately, be it 192, 168, 32, and then 40. And then we will convert that IP address into binary by using our master formula. And that master formula is 128, 64, 32, 8, 4, 2, and 1. This is what the master formula is. And what you need to do in order to come up with the outputs or with the binary conversions is select the octet, because what this is nothing but you can say 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, up to 2 to the power 7. So 2 to the power 0 is 1, 2 to the power 1 is 2, and 4 and 8 and 16 and so on. 2 to the power 7 is 128. That's how the values are actually divided. You get that? And these are all 8 numbers. So you have 1, 2, 3, 4, 5, 6, 7, and 8. You have these 8 numbers there, and each number represents the specification or represents the location of 1 bit in every octet. So how you do the calculation or how you do the conversion is pretty easy. What you need to do when you know about the dotted decimal or when you know about the number that you actually want to convert into binary, which is for us, I would say 192, then you need to look for that value inside this formula. Do we have 192 over here? So you look for that value directly into the master formula. Do we have that? No, you don't have that. Right? So what will you do? If you don't have that value, you figure out the numbers by adding which you can actually get that value. For example, if I add 128 with 64, what will be the output? 128 plus 64 is 192. So that's how I come up to the result. As I have got that by adding the first and second bit, I can get the result as 192. So whatsoever bits that I can add in order to get the desired result, those bits or those numbers location will be set to 1. So when I say 1 and 1 for 128 and 64, then the result will be 1 1, and rest of the 6 digits 1 2 3 4 5 and 6 will be 0, like that. This is pretty easy, right? Let's say if you want to figure out the number for 168. Now 168 also is not available in our master formula. It's not there. So what you need to do, you need to come up with values that by considering which uh, you can actually figure out the binary bits. So if I say I can add 128 plus 64, but you cannot do that, right? It will cross the value and it will become 192. So what you do, you skip 64. Then you go to the next one, which is 32. If you add 128 plus 32, then how much it becomes? 160, right? Still it is less than the desired output. So how much more do you need? 8, right? So you cannot take 16, but you can take the next 8. So you say plus 8, and then the output becomes 168. Now, how many values did you take? You took 128, you took 32, and you took 8. So you set 128 as 1, 32 as 1, and 8 as 1. And rest of them will be 0. So the binary becomes 101010000. You understand that? Yeah, just like that, if you go for 32, 32 is directly available there, right? So you say 00100000. Only third location will be enabled. And for 40, it will be the combination of 32 plus 8. That becomes 40. So you say 00101000. And that's how you come up with the binary of 192, 168, 32.40. And you say 110 00000 dot 101010000, and then 0010 and 001 000. This is the binary conversion for 192.168.32.40. You understand that? Makes sense? That's how the thing actually works here. Now what I'm gonna do, I'm gonna give you certain IP addresses and you need to figure out the binary conversion for those IP addresses and see if you're comfortable doing that. So the first IP address that I'm giving you is 157.212.73.97. That's the first IP address. Then the second IP address that I'm giving you is 113.169.83.211. You get that? Then the third IP address is 74 dot, I would say 91 dot 183 dot, again 53. And then the fourth IP address, which is the last one, is 232 dot, 171 dot 71 dot 145. These are the four IP addresses that you need to convert into binary. I'll take each and every IP address one by one and I'll consider the same. So if we talk about the first IP, which is again, let's take the first IP address, which is 157.212.73.97. So if we consider 157, 157 is addition of 128 plus 16, okay, plus 8, and it becomes then 152 plus 4 and plus 1. So this is how you become 157, or this is how it becomes 157, right? So the answer for this is going to be 1 0 0 1, then 1, then 1, and then after that 1 0, no, it's gonna be, yeah, 101, like that. So you have 128, then you have 16, 8, 4, and 1. That's how you come up with 157. Then, in order to come up with 212, 212 can be achieved with 128, then 64. And then after that, you can achieve it with 16, and then 4. That's how you come up with that. So the answer for that will be 11011100. Correct? For 73, it will be something like 64 plus 8 plus 1. So you're gonna have 0, 0, oh sorry, 0, 1, and then 0, 1, 0, 0, 0, 1, like that. Or yeah, this is kind of a wrong one. I would say 0, 1, 0, 0, 1, and then 0, 0, 1. Yeah, that's how you come up with 73. And then 97 will be pretty simple. It's gonna be 64 plus 32 plus 1. So you can say 0, 1, 1, 0, 0, 0, 0, 1. That's how the output you become. It becomes for 157, 212, 73.97. Makes sense? You can match up your answers with this. Yeah, 212 is 128 plus 64, and 128 plus 64 becomes 192. Then plus adding 16, it becomes 208. Plus adding 4, it becomes 212. So for that, it will be 110. Ah, I have did something wrong here. So this will be 110, and then 1, and then 0, 1, 0, 0. That's how it will be. Yeah, 212 is corrected, and that's how the configuration, or that's how the thing would look like. So you can think about other domains over there, how they can be actually configured there. And yeah, that is so. Usually when we talk about, or even if I say, or when we even keep these things, so when we look at the classes, the class actually starts at 0 and it ends up at 255, meaning if you have any IP address, then any octet of that IP address cannot cross 255. You need to have a value which is lower than 255 there. Makes sense? I cannot have an IP address that starts at 300.12.0.1, right? Or I cannot have an IP address that says 192.168.1.270. This cannot be any IP address. This is all wrong IP address. And if we consider an IP address of any class, then that particular class IP also doesn't like takes you beyond 255. But why so? Because there is binary requirements or binary conditions there. So when we say that the minimum value that you have, the minimum value with the binary that you can have can be all zero for all octets. So this is what you can have. And maximum what you can set is all ones. So when you have all zero, the decimal is going to be zero itself. But when you have all ones, then you will be adding every digit that is mentioned there. So 128 plus 64 plus 32, 16, 8, 1. You will be adding everything here. And the addition of that will become 255 as a result. Makes sense? That's why you do not have any IP address that goes beyond 255. That's the limitation over there. You get that? And this is exactly how it works here. Also, if we talk about class A, so there is an exception with class A, that when you consider consider an IP address or consider the range of class A. Class A starts at 0 to 127, but the usable range in class A is only till or only from, you can say, 1 to 126, because 0 is reserved and 127 also is reserved. And why so? Because 0 is reserved for the purpose of default routing and some other purposes, and 127 is reserved for loopback addressing. You get that? These are some of the purposes why these addresses are reserved. Cool, do you understand that? So it is only with class A that you cannot use the complete addressing scheme of class A. You can only use from 1 to 126 there. And now, as this is how IP addressing actually works. So I hope you understand that. Loopback is actually an IP address which is used for the virtual interfaces of every system that you can have. So if, for example, there is a PC and that PC is connected with some other systems or some other, let's, hub, and that hub also has also PC or different PCs connected. So if this cable is break, or if this like network interface card is working or not, in order to check what is the issue, then in that particular thing, you you can use, go to this PC and you can try to ping your loopback interface 127.0.0.1, and if this ping is successfully done, then it means that there is no fault into the NIC card and NIC card is all good. There is an issue in the cable connection here that you are doing. So loopback interface is for troubleshooting the local interface that you have onto the PC. However, about default routing, we'll be talking about that in the coming sections. Okay, yeah, local hosts also use default addresses. But yeah, so that was the section that we had to cover about the basic IP addressing. Now, the important or more important part that we're going to talk about is subnetting. So, to begin with, now this is the most or one of the most important topics that you will have in your networking journey. Okay, you need to be way good than you are in subnetting, and practice is the only thing that is going to make you even perfect in subnetting, according to my experience. So I would say, request you to pay your attention here as we discuss subnetting. So as I said, the only public classes that we use is class A, it's class B, and class C. And class A uses a range of 0 to 127. Class B uses a range of 128 to 191. And class C uses a range of 192 to 223. And each of this class has certain limits there. Okay, and these limits, or I would say these classifications, are done with the name or with something that is called as prefixes. So there are two type of prefixes. One is called as network prefix, and the other is called as host prefix. One is network prefix and the other one is called as host prefix. So when we look at class A, then class A has a prefix range like this: network, 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 host. And class B has its range as network, network, host. Oh, sorry, that's kind of a wrong one. Class A has its range as network, host, host, host. Class B has it as network, network, host, host, and class C has as network, 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 and host. And then the default subnet mask, if we consider that, is 255.0.0.0. Class B has a default mask of 255, 255.0.0, and class C has 255.255.255.0. You get that? This is how the requirement is. Now, what is this network prefix or the thing that I have mentioned there? So when you look at this, then it can be understood in a way that let's say you have a network that gives you the ability 192.168.1.0. This is the entire network, and the number of IP addresses that you can have starts from 1.0, 1.1, 1.2, 1.3, so on. It goes till 1.255. So you can say that the total number of IP addresses that you have is 256, right? Now assume this as compared to one of the example that I can give you here is there is a classroom, and in that classroom, let's say that there are 90 benches, okay? And these 90 benches are occupied by only 60 students, which means you still have 30 benches that are vacant in the class. Just like that, out of the total network that you have, which is 192.168.1.0 network, you have 256 IP addresses, out of which there is a local area network which is being created, and for that local area network, only 100 people are using that local area network that you have. Makes sense? And the IP addresses that they're using is between 192.168.1.0 till 192.168.1.100. These are the IP addresses that are being used by the number of people that you have in a network. Now tell me one thing, that as these guys are connected into a local area network, would they be able to communicate with each other without any routing or so, just by having the IPs in the network? Yes, no? Would these 100 people be able to communicate with each other? Yeah, perfect. So most of you are saying yes, right? And that's correct. They should be able to communicate. Now tell me one thing, that out of these 100 people, let's say that there is a user who has an IP address 192.168.1.43, and this 192.168.1.43 user changed its IP address to 192.168.1.143. Makes sense? Which means that 43 now became vacant. So will this newly configured IP address user be able to communicate with the other 99 users? Yes, no? Some are saying yes, some are saying no. There is no routing that is done yet. Uh-huh. So see, the answer is that the user will still be able to communicate with each other. Okay, the user who has changed his IP address to 192.168.1.143 will still be able to communicate, because we have not changed the network prefix of that particular IP address. So when I said that the network that you are using is 192.168.1.0, right? Which means it's a class C network. How many network prefixes do you have? 3. How many host prefixes do you have? 1. So which means that in order to be able to be into that same network or be into the local area network, the IP address that you need must have its first 3 octets into the same network that you have, like 192, 168, and 1. They get that? Then and then only you will be able to communicate with the other users or with the other people that are there. You get that? And as this user changed its IP addresses last octet from 43 to 143, so it will not be any problem for it to communicate with each other. You see that? Just like I gave you an example of this classroom, that there were 90 benches and only 60 were user. So the scenario was being specified in a way that only like one guy from that 60 students like stood up and he changed his bench to someone to some vacant bench, but he still is available into the same classroom, right? If I say that this is a classroom and then that classroom has 90 benches and out of that only 60 students are available, so I can say bench number 1 to bench number 60 is being used by these 60 people. Now what I'm saying is the guy 43 wake up and change the bench number from 43 to bench number 83. So what did he do? He will still be able to stay there in the classroom and he'll be able to attend all the lectures that are being conducted. Make sense? Just like that, when I have the entire network of 192.168.1.0, I have network prefixes as this, this, and then the last octet is host. So what I need to ensure that my first network octet or my first network bits needs to be same. You get that? And if I'm out of the available IP addresses from 1.0 to 1.255, only 100 are being used, which are 1.1 to 1.100, let's say. Still, you have 1.101 to 1.255. All these IP addresses are vacant as of now. Make sense? So if a guy who has 192.168.1.43 changes its IP address to some of the IP address over here, which is 192.168.1.143, then he still is into the part of the network. He still is in the same local area network there. You get that? Yeah. Now, if the same guy changed its IP address to something like 192.168.2.43, now will he be able to communicate with the rest of the 99 guys? Exactly. Now that particular user will not be able to communicate with the other guys, because what he did, he changed the network prefix, he changed the third octet of that particular IP address to 2, which means he is no longer part of that particular network. Make sense? That's how it works. So the only condition over here that I'm specifying, that in order to stay in a local area network or in order to be able to communicate with the other users without implementation of routing, you need to have your IP addresses as the same like in the same network as the other user. If that particular other user, like there are two PCs and these two PCs want to communicate together. And if you have an IP address like 192.168.1.1 here and 192.168.1.10 here, then you guys will be able to communicate together. Success. But if on the other end, the IP address is 192.168. I would say 2 dot something 2.10, then this particular IP address will not go and it will be unsuccess. Make sense? Because the first 3 octet which actually should match doesn't really matches. They are different. Yeah, good. So that is how the prefixes actually work. And with keeping that in mind, you have different subnet masks as well that are dedicated to uh, each and every class that you have. So you have a subnet mask of 255.0.0.0 in class A. Then you have 255.255.0.0 in class B, and you have 255.255.255.0 in class C. Makes sense? And when you have that, then you can consider, for example, tell me one thing now. If you have a requirement of, of something, like you have an office requirement or office scenario, that you need to create 5 different networks, and in each network there should be 30 users or 30 users per network. This is what the scenario is. So how will you configure these networks? Which means that you have this one network in which there is going to be 30 users or 30 computers. This is the second, I would say, network in which you have 30 users. Then you have the fourth network or third network, which is 30 users. And then you have this fourth network, which again has 30 users. And the fifth network, which has 30 users again. Make sense? Yeah. So when you talk about this, then how you can design these networks, because these networks should not be able to communicate with each other. No intercommunication is allowed. There shouldn't be any intercommunication that needs to be done. So if you think of a normal scenario, then you will kind of configure 5 different networks, and those networks might be in a way that 192.168.1.0 might be the first network. The second network that you might take can be 192.168.2.0. The third network might be something like 192.168.3.0. The fourth network might be 192.168.4.0. And the fifth network will be 192.168.5.0. These can be the 5 networks that you would think of. So you'll get 1.0 here, you'll get 2.0 here, 3.0 here, 4.0 here, and 5.0 here. So that no one gets able to communicate with each other, as the network prefixes of the third octet will be different. Correct? Now in this scenario, can you tell me how many IP addresses are we using from each network? From each network, we only use 30 IP addresses. And how many are we getting? Each network has a capacity of using 256 IP addresses. You get that? So if we look at the total waste that you have, that waste will be 256 minus 30. It will be around 226 IP address will be wasted per network. You get that? If this is the scenario. So for such scenario, how do you use subnetting? There comes the part of subnetting. So what do? You actually take the entire network and then you divide it according to your requirement. Because if you are using that 30 IP address, we cannot say that the remaining 226 IP address can further be used in some other network, because that will be conflict of IP addresses then. You cannot use same IP network into 2 different network environments. That will be conflict of IP addresses there. So when you have such scenario to be implemented in this way, then the way you communicate or the way you organize your network is by dividing this network into different sub networks. And this is exactly the process that we call as subnetting. You're taking the entire network and you are dividing it by making it as act as a subnetting. Make sense to you? So let's talk about the why do we actually need subnetting. Yeah, What I'm saying that I'll repeat it one more time. No, not an issue there. So consider this scenario. As I told you that you have an office requirement where there needs to be 5 networks and there needs to be 30 users per network. So when we say that you actually need 5 network and you need to use 30 users per network, in that case you might think of using these 5 networks: 1.0, 2.0, 3.0, 4.0, 5.0. Now in this each network, there is one last octet which acts as host prefix, which means you can assign different host prefix to different IP addresses. And in that scenario, you will be using only 30 IP addresses from each network. And the total number of IP addresses that you're getting is 256. So how many IP addresses are going waste? If we say the total IP minus the used IP, then you are wasting around 226 IP addresses there that will actually not be used in any of the scenario there. Cool. So whenever you have such scenario, then what do? Because the main purpose is not to let the other networks or not to let the different networks communicate with each other. And for achieving that, what do is you divide that particular major network into different parts of the network. Just like if you have purchased an entire floor of a building, and that particular floor can actually vacant around 1000 people. Let's say that this is a floor, or I'll use a pen. Yeah, this is a floor that you have purchased, and this floor has an ability to host 1000 people. Make sense? Now, you have 4 different departments in your company. One is sales department, the other one is marketing department, then the other one I would say is admin department, and then you have an HR department. So when you want to divide this floor in these like around 250 people each department, then you will make a partition in this floor like this, right? So this particular section, sales people will sit over here, marketing people will sit over here. You can say that HR people will sit, and here admin people will sit. Just like that, same thing will happen with the network as well. If you have a major network which actually provides you around 256 IP addresses, then you need to assign different IP addresses to different departments, right? So for example, if you want to divide it equally, then you will assign 64 IP address here, 64 IP address here, 64 here, and 64 here. Instead of using different networks like 1.0, 2.0, 3.0, 4.0, you use just 1.0 and you divided that big 1.0 network to smaller 4 different networks. That is the concept of subnetting. Do you understand that? Perfect. So for our same requirement, what we are going to do is the office scenario that I gave you. In that scenario, what we are going to do is we will only use one single network, and that single network is 192.168.1.0. Now there is another term that is used, and that particular term is called as CIDR. And CIDR stands for classless inter-domain routing. Classless inter-domain routing. What is this classless inter-domain routing? This is like a number which is represented by using slash notation. So when you have the subnet masks that are listed, then if I just convert the subnet mask, which is, let's say I'll take 255, 255, 255.0. So CIDR actually represents number of network bits in your subnet mask, which means that if I have this subnet mask and if I convert this into binary, then can I say that as I have 255, It means that all the octet from all the bits from my master formula is set to 1. Like this is how the binary subnet mask it will look like. Correct? This is the binary conversion of the current subnet mask that I have given. So when we consider this subnet mask is the default subnet mask for class C, which actually has 3 octets for network and 1 octet for hosts, right? So we can say that this is network, this is network, this is network, and that is host. So you need to actually look into the subnet mask and figure out that how many bits are dedicated for the network prefix. Can you tell me how many bits are there for network prefix? 24, right? You have these 8, these 8, and these 8. So that's why we will refer to the subnet mask in a short form called as /24. So when you see any subnet mask that has, or when you see the default subnet mask of class A, the CIDR value for that can be /8 because it will only have 1 octet dedicated to network prefix which contains 8 bits. When you look at the second one, then class B has a CIDR value of /16, and then the class C will have the CIDR value of /24. You get that? This is how the CIDR values are used. And the CIDR values is the simplest form of representation that you can have for your network. Cool. Now let's go and see how the subnet mask actually can be brought up. So the network that we need to work with is this. We want to work with a network called 192.168.1.0/24. This is the network that we have been provided of, and we need to create 5 networks out of this, each with 32 hosts. And again, considering the Brahmastra that we call it in India, or the master formula, you can say this is how it looks like. Make sense? So when you do subnetting, in subnetting, there are certain things that you need to take care of. That 4 things that needs to be calculated. The first one is number of networks. The second thing is called number of hosts. The third thing is called as number of, I would say, sorry, the third thing is called as subnet mask itself. And the fourth thing is called as ranges, or you can call it as block sizes as well, or blocks of networks as well, whatever you want it to be. So when we say that these are the 4 things that you need to calculate, the number of network can be calculated with a formula called 2 to the power number of borrowed bits. And I'll explain you what is called as borrowed bits. The second thing is 2 to the power number of off bits. Then you have subnet mask, and then you have ranges. Make sense? Now, as you see, we need to figure out these values for slash 24. So the first step is to write down the CIDR into the binary form in order to make it easiest. Okay. So when we have slash 24, what will be the binary form? Binary form will be 1111111 and then all zeros. You get that? So when you have this, it means that the first octet by default is dedicated to network, the second one is dedicated to network, and the third one is dedicated to network. And the last one is dedicated to host. Correct? Now pay attention over here because this is a crucial part. When you make changes into the host prefix that you attempt to convert these host numbers into network numbers. For example, this is the default one, but you create a new subnet mask or you create a new CIDR value where you are changing the host prefixes from all zeros to this. So what you did, you changed first two bits from the host prefix into network bits, which means you borrowed the first two bit from the network prefix, from the host prefix, and you converted that into network. And those will be the bits that we will call as borrowed bits, which means the number of bits that you make change into host prefix will be called as borrowed bits. Do you understand this? Currently, we don't have any borrowed bits in our network. Make sense? Currently, we don't have any borrowed bit. So that's why the formula for figuring out number of network will be 2 to the power 0 because number of borrowed bits is 0. We have not converted any host prefix into network prefix yet. So we say number of network is 2 to the power 0 there. And what will be the output? 1. So we just have one network there. Then you need to figure out number of off bits. Off bits means number of zeros in your CIDR. How many number of zeros do you have? You have 8 zeros, correct? 8 zeros you have, not 6. So that's why we will say number of hosts is 2 to the power 8. And that will kind of give you 256 number of hosts in one network. You get that? And the subnet mask for the same will be just the I would say dotted decimal conversion of the CIDR, which will be slash 24 means 24 on bits. First 8, second 8, and third 8. And then the last octet will be 0. You get that? And then the range will be in a way that you will start the network from the 0. So you will say 192, 168, 1. This is going to be constant, right? As the part of the network prefix. And you will start from 0 and then you will end up at 192.168.1 dot. The last IP address will be 255. And totally you have 256 IP addresses, and in each network, like you have the number of network as 1. Make sense to you? And there is also a term called valid hosts. So valid hosts is equal to number of hosts that you have minus 2, which means valid host will be 256 minus 2, that is going to be 254. Why so? Because first IP of every network is called as network ID, and last IP of every network is called as broadcast ID. Do you understand that? First IP address of every network, which means 192.168.1.0 will be reserved as network ID, and 192.168.1.255 will be reserved as broadcast ID. So the usable IP address will be from 192.168.1.1 to 192.168.1.254. That's the range that is gonna be. Hope you understand that. Perfect. Now I'll give you another example to understand subnetting even much better. Let's say that we, as we have the number of network as 5 requirements, right? And the host as 32. Let's consider the same thing because this is what we have just figured out the numbers as default ones. So I'll now consider our requirement, and based on that requirement, I'll come up with the formula. So again, we get provided with the network that is 192.168.1.0 slash 24, right? And we have 5 networks and we have 30 hosts. Good. And then I'll write down the master formula: 64, 32, 16, 8, 4, 2, and 1. Make sense to you? Now over here, what we need to figure out, the first thing is, again, number of network. The second thing is number of host. The third thing is subnet mask. And the fourth thing is ranges. Now, the very first thing that we do is write down the CIDR into binary again. So we will have a CIDR of, or the subnet mask of this network, 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 and then you will have host as these heads. Make sense? Now what is happening here is you have a requirement of 5 networks. Now if you have your host prefix as these and your network prefix as these, then have you borrowed anything? You have not borrowed anything. That's why the number of network will just be 1 then. But if you want 5 networks, then you need to select the value for the number of network that you can cater based on this formula. You cannot directly get the value that is 5. You can get a value in this range. You can get 1, 2, 4, 8, 16, 32, 64, 128, and so on. So what will be the nearest value from the formula that is like that covers your requirement? Can we go with 4? We cannot go with 4, right? So what will be the nearest value that you can come up with? The nearest value for 5 networks is 8, right? You cannot go with 4. So the nearest value can be 8 networks. Make sense? Now in this case, you have selected 8 here. And what is this 8? This 8 is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. 2 to the power 3 is equal to 8. And when you figure out that the power of your chosen value is 3, it means 3 is the number of bits that you will borrow. Again, understand it. Are you good selecting the nearest value based on the requirement? If your requirement is 3 network, you will go with 4. If your requirement is 5 networks, you will go with 8. If your requirement is 10 network, you will go with 16 network, because you need to select a value that goes into the power and not normally of that. Make sense? And for that, as you figured out that 8 is going to be the number of network for you, which means that 8 is 2 to the power 3. And when you get it that 3 is the bit, it means that you need to borrow 3 I would say first bits from the host. So you convert these first 3 host bits into network bits, and now the last octet will become 111, and then the remaining 5 will become 0, which means that from the entire host portion you divided that host portion into two portions. It became network, and then you have this as host. Are we good here? Perfect. And this specifies that the number of network for you is going to be 2 to the power 3, which will give you 8 networks. Cool. And then what is the value for number of hosts? Number of hosts is 2 to the power number of op bits. How many op bits now do we have in our entire CIDR? Can I say 5? 2 to the power 5. And that gives you 32 hosts. Make sense? This is how you come up with number of network and number of hosts there. And then the subnet mask. Now the CIDR value, as you have modified it, changes from /24 to /27. You get that? Because now the total number of on bits is not 24. The total number of on bits have become now 27. That's why for /27, the CIDR will be 255.255.255. These are the first 24 bits. Then you need to add the first 3 bits from the master formula. And 128 plus 64 plus 32. So you say 224. Do you understand that? Great. So you can see that one formula can help you in many different ways. You need to just use that again and again. Cool. And then how would the ranges be divided in this? The ranges will be divided in a way that, yeah, I'll explain it again, Vaibhav. So see, as of now, what you have is /27 is how you have figured it out. That /27 is the CIDR for your requirement. Is it good with you? Vaibhav, please reply. So when you need to figure out the subnet for /24, you just need to convert it into binary. So when you have the binary for 27, it would look like this: 8, 8, 8, and then 1, 2, 3, and then like this. So if you want to convert this octet into dotted decimal, then you just take the help of this, like 128, 64, 32, 16, 8, 4, 2, and 1. And you just put your values inside this formula. How many bits do you have on? Everything, right? All the 8 bits. So you just add everything, and that becomes 255 over here as well, over here as well, and over here as well. Now from the last octet, you just have first 3 octets that are turned on. So you will only add first 3 octets from this: 128, 64, and 32. And that will become 224 as the subnet mask. Hope you understand that. Yeah, if you borrow, I will explain that, Amar, don't worry. So this is how it works for you, okay? And then you will start writing down the ranges. Then the ranges will be starting from 192.168.1.0, and it will end up at containing 32 hosts. 192.168.1.31. It will not end up on 32 because we are starting with 0. We end up at 31. Then the next network will start from 192.168.1.32 and it will go till 192.168.1.63, then 1.64 to 1.95, 1.96 to 1.90 to 1.127, 1.128 to 1.159, and 1.160 to 1.191 and 1.192, wait, yeah, to 1.223 and 1.224 to 1.255. How many networks are these? 1, 2, 3, 4, 5, 6, 7, 8. Do you see that? Totally, you have came up with 8 networks, and each network has 32 hosts inside of it. What will be the valid host? The valid hosts will be 30 according to your requirement. Do you understand that? So every network that you have, 1.0, 1.32, 64, 96, 128, 160, and so on, so all these will be the network IDs, and all of these will be the broadcast IDs. Do you understand that? Yeah, that is exactly how you do subnetting there. Make sense? I hope most of you understand this thing. And those who do not understand it, I would, yeah, the range is just the combination of number of hosts that you have. If you have 32 hosts, then you start at 0 and end up adding 32 into it. Then start with the next one, then end up adding another 32. Like that, you just figure out for the number of networks that you have. And as our requirement is there, we will only be using the first 5 networks. So we will be using this, and this. These are going to be the 5 networks that we will use. 1, 2, 3, 4, and 5. And the remaining 3 networks will still be reserved for us. Those are kind of the empty, I would say, those are kind of the empty networks or empty floors or empty cabinets. You can assign values there later. Among this formula, someone is posting into the chat that you didn't understand this. So this formula that we have, 128, 64, 32, 68, 4, 2, and 1. This formula is nothing but 8 different values in an octet. Okay. The first value is 2 to the power 0. Second value is 2 to the power 1. Third value is 2 to the power 2. Fourth value is 2 to the power 3, 4, 5, 6, and 7. Make sense? And as we have 5 networks, the nearest value is 8. So when we choose 8 as the number of network, the number of network actually can be written down in this way, 2 to the power 3. You understand? And that's how we reserve 3 bits there. Hope you understand that now. Exactly. Now what I'm going to do, I'm going to post up some, I would say, exercises here. So go ahead and see if it works for you. What you need to do now is, for me, you need to do this exercise. Figure out all these 4 things for 2 networks, 192.168.1.0/25, and do it for 192.168.1.0/26. Try to figure out the things for these 2. Okay, figure out number of network, number of hosts, subnet mask, and ranges, and the valid hosts for both of these, and see if it works for you. Okay, So yeah, people have started putting their answers into the screen or into the chat section, and I can still see that slash 26. So you guys can start putting your answers in the chat, and I believe we are good with what we have done. Okay, I see most of you are. So I'll write the answers here. That for the first network, I'll divide it into two. For the first network, which is 192.168.1.0/25, the number of network, the number of host, the subnet mask, and ranges will be according to 2 to the power 1 will be the number of network, because 24 and 25 we just borrow one host, right? So number of network will be 2, number of host will be 7, because if we keep one bit off, 7 will be off. One bit on, 7 will be off, so that's going to be 128. So we'll have two networks, each of 128. Then the subnet mask for the same will be 255.255.255 dot 128. And then the ranges will be, the first network will be 192.168.1.0 to 192.168.1.127. And the second network will be 192.168.1.128 to 192.168.1.255. That will be slash 25. If we talk about 192.168.1.0/26, then the number of network, number of host, subnet mask, and ranges will be accordingly. Number of network will be 2 to the power 2, which is 4 networks. Number of hosts will be 2 to the power 6, 64. Subnet mask will be 255.255.255.192, and the ranges will be from 192.168.1.0 to 192.168.1.63. Then 192.168.1.64 to 192.168.1.127, and 192.168.1.128 to 192.168.1.191, and then 192.168.1.192 to 192.168.1.255. That's what the thing will be. Okay, and I hope most of you are correct over there. You can verify your answers with mine.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
And here we go. We will start right now in order to discuss about the second session of the day. And yesterday we did discuss about the very fundamentals of networking and how it actually works with IP addressing and prefixes and subnet masks and so. There you go. I hope you all can see my screen now. So yesterday we did discuss about class C subnetting, right? In which we discussed about different subnets, be it /25, /26, /27, and so on. However, I'll just review the same. And today we are going to discuss about class B subnetting and class A subnetting. So in order to review the same, if we talk about a subnet mask, let's say 192.168.1.0/28, let's say. So to figure out the number of networks, number of hosts, subnet mask, and ranges, the formula that we have been using in the previous class was something like number of network, then number of host, and then subnet mask, and ranges. That's exactly how what the four things that you actually figure out. Okay, when you do any type of subnetting. So perfect. So first thing first is when you like have a subnetting to be done, then what you need to do is you need to convert this CIDR into the binary bits first. And when you convert it to the binary bits, then you actually do write it down in a way. The first 8 bits, the second 8 bits, the third 8 bits. And then as we are talking about 28, so it means that you have borrowed 4 bits from the host portion, and then rest of the 4 bits are going to be same for you. Makes sense? So you can say this is network, 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 again network, and the host. This is how the network is actually divided. And that kind of brings you that the number of network that you're going to have is 2 to the power 4, which will be 16. And then the number of hosts will be 2 to the power 4 again, which is again 16. And the subnet mask can be figured out with our master formula, which can be 128, 16, sorry, 128, 64, 32, 16, 8, 4, 2, and 1. So as we have turned on the 4 bits, we just put the first 4 bits, add them together, and that's how you would write down the subnet mask to something like this: 255, 255, 255 dot 240. Because if we add 128, 64, 32, and 16, it becomes 240. And the range, of course, will start from 192.168 dot 1.0, and it ends up at 192.168.1 dot 15. That's how it's gonna end. The second network then, however, will start at 192.168.1.16, and it will end up at 192.168.1.31. And then the next one will start at 32 and end up at 49, and 50 to 63. Okay, like okay, this is going to end up at 47, and it will start at 48, not 50. So yeah, that's how the thing are going to go. And then the last subnet will be 192.168.1.241, and it will end up at 192.168.1.255. And totally, these will be 16 networks, each having 16 IP addresses per network. And the starting IP address of every network is going to be network ID, and the ending IP address of every network is going to be the broadcast ID. Make sense? Do you understand that? So this is how we actually do class C subnetting. However, the number of bits that you can have in class C can go till /32, because you see the last 8 bits or the last 8 values are dedicated for the host portion, which actually starts at 25th bit. Then you have 26th bit going towards 31st, or sorry, 32nd bit, right? Like that. So when you actually see that 32nd bit can also be done, but you cannot really have subnetting that can be done for /31 or /32. And why we can't do subnetting for /31? Because when we figure out that /31 can actually be subnetted, but then the output of that comes that number of network would be 2 to the power 7, which will be 128 network. Number of hosts will be 2 to the power 1, which is going to be 2. So as you will only have 2 IP addresses per network, these 2 IP addresses will be counted in a way that the first IP address will be network and the last IP address is going to be broadcast. Make sense? So there won't be any IP address that will be left that can actually be used to be assigned to any of the interface or so. You get that? So that's why we do not really use /31. And same is going to happen with /32 as well. that you won't be able to consider or have any of the IP address that can actually be assigned to someone. Makes sense? This is how the thing actually works over here. I hope you understand that. So after figuring out that how slash C subnetting actually works, what we are going to do is we are going to consider doing slash B subnetting. And class B subnetting spans from slash 16 to slash 23, which means if we look at the default subnet mask, then class B has a range of IP address starting from, or the first octet can be from 128 to 191, right? And then the network prefix and host prefix calculation for class B is equal. So you have two network prefixes and two host prefix, and the default subnet mask is 255.255.0.0. You get that? This is how the scenario is over there. And let's say that you want to figure out a subnet mask, or if you want to figure out subnetting for a network that starts at 172.16.0.0 slash 23. And for this subnet, you figure out number of network, you figure out number of host, you figure out subnet mask, and you figure out ranges. You get that? So number of network can be calculated, or number of network can be thought of in a way that 2 to the power 7, 2 to the power, uh, now 2 to the power 7, if we think of that, number of network can be 128. And how much would be number of hosts? 2 to the power 9. Because if you think of it, if you think of this CIDR in a way of binary, then by default you will have 16 bits as on 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. Then when you consider the same thing over here, you can say that by default, these all will be the host prefixes. Correct? So these are the network prefix, or you can say, and these are going to be the host prefix. This is the default scenario. And in this case, you will consider that the CIDR for this is slash 16. But as you are having the CIDR for, you can say, slash 23, then what is going to happen over here? The binary bits will be converted in a way that first 7 bits will be borrowed from the host prefix and they will be converted into network prefix. You get that? So that's why we are going to, I would say, erase the first 7 bits. And then we are going to convert those 7 bits into, right? And then we will write it in a way that this is again going to be the network part, and then you will have a host part like this. And now you can see that totally there are 23 ones, and then there are 9 zeros. We consider 7 as borrowed because we are working with slash 23, and by default slash 23 is part of class B. So that's why we say that slash 16 is the default one. And then after that, as we are moving for slash 23, so we will consider that 23 minus 16 is 7. So 7 will be acting as borrowed bits. Make sense to you? And then the remaining number of hosts are going to be 2 to the power 9. And that 2 to the power 9 value for that will actually result into something called 512. which means that you're going to end up having 128 such networks. And in every network, you're going to have 512 IP addresses there. You get that? Then we will write down the subnet mask. And the subnet mask for slash 23 is going to be written in a way 255.255 dot. And then after that, you will use the same master formula 128, 64, 32, 16, 8, 4, 2, and 1. And what you're going to do for the third octet, you're going to add these 7 bits according to the master formula. And then you're going to put it over here. And how what those value will be? That particular value will be 254.0 because the last octet is all 0, right? That's why the value will be like that over there. And then the ranges start. So this is the most crucial part of our understanding the class B subnetting. Okay, in that, where do we start? We start with 172.16.0.0, and we end up at 172.16.0.511. Do you see? Can we write that particular network like this? Is it correct? No, we cannot write that like that, right? And for the same, how would you write it down? You will write it down in a way that if your network starts at 192.168.0.0 or 172.168.0.0, then it will of course end at 172.168.255. It cannot cross the boundary of 255 or cannot go to 256 or so. So how do you make it work then? Then you go and change the third octet. You get that? If you have heard if you have seen the speedometer of a car or something, you have different like numbers there or digits there. Let's say these are the 5 digits that you have. And when the last digit actually goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, then it again starts from 1. But for that change to take an effect, this particular last second bit will also change to 1. And then the value will start from 11, 12, 13, 14. Once it reaches to 9 again, then again the second iteration will start, but the second update will change to 2. You get that? That's how you reach out to 100. So when you see this, then once your last octet reaches out to its limit, that is 0 to 255, then you can say that you start with the third octet then. So you will write the next network like this 172.16.1.0 to 172.16.1.255. And when you combine both of these networks together, if you merge both of these networks together, how many IP addresses are you going to have? For the first network, you're going to have 256 IP. And for the second network, you're going to also have 256. So when you merge them together, totally you have 512 IP. So if I write it down in a way that the network actually starts at 172.16.0.0 and it ends up at 172.16.0.511, then this is a network that contains 512 IP address, out of which 0.0 will be the network ID, and sorry, not like this. This will be written as 1.255. Yeah. So we are starting over here and we are ending over here directly. So over here you can see that 0.0 is the network ID and 1.255 is the broadcast ID. And when you specify that, you can say that the network here contains 512 IP addresses there. Make sense? Just like that, the next network now will have something in a way that as we are going to start with this, then let's write it in a good manner. And the first network now is going to be from 0.0 to 1.255. Then the next network will be 172.16.2.0 and it will end up at 172.16.3.255 and then 4.0 to 5.255. So if you know that we are actually merging here two network octets per network there. Okay, one segment is equal to 256. So what we are doing, we are merging multiple segments over here. And then by merging multiple segments, you are actually forming up one of the network that is required there. So like this, you are gonna have 128 network. And when you reach out to the last, your last network will look like 172.16.254.0 to 172.16.254 dot sorry 255.255. That's how the network will be, and totally you will have 128 networks. Each network having 512 hosts per network. Do you understand this? Great. Now here's the thing. How do you figure out that how many number of segments do you need to merge? Like over here, if you consider that 0 and 1, 2 and 3, 4 and 5. So you can say that you are merging around two segments of 256 IPs for each network here. Now, last network will not be 255.0, it will be 255 itself. So how do you figure out that how many number of segments should be merged here in order to figure out the value? So you just consider a logical operation here that whenever the number of hosts is gives you a result that is greater than 256, then divide that particular value by 256. If your number of hosts is coming up with a result that is 256, that is greater than 256, then divide by 256 itself, and then the answer to that will be 2. Make sense? And this is how you actually figure out that what should be the number of segments that you need to merge together. So over here we have merged two segments: 0, 1, 2 and 3, 4 and 5, 6 and 7, like that. You get that? Let me give you another example there. If you work up with something, if you work up with something, for example, 172.16.0.0 slash 22, let's say. For this, we will figure out number of network, number of host, then we'll figure out subnet mask and ranges. So the number of network over here can be 2 to the power 6, right? Which is going to be 64. The number of host can be 2 to the power 10, which can be 1024. And then a subnet mask will be 255.255.200, yeah, 252.0. And then if you need to figure out now what should be the ranges, because the range of course will start at 0.0, but would it end at 1024? So you need to divide this value by 256 and the number of segments that needs to be merged will come out as 4. So when you start at 0, you actually end up at 3 because you need to merge 0, 1, 2 and 3 because 0.0 will end up at 0.255. Then you will start with 1.0 to 1.255, then 2.0 to 2.255 and 3.0 to 3.255. And entirely each of that particular network has 256 in each network multiplied by 4, that gives you 1024 hosts, like this. So you start up at 0.0 and you end up at 3.255. Like that, you merge four segments. Just like that, when I said that your network is going to start then at 172.16.0.0 and you will end up at 172.16, I would say 172.16 3.255, and then you will start at 172.16 4.0 and end up at 172.16 7.255, and like that the last network will be like 172.16 0.0, sorry, not 0.0, 252.0, and you will end up at 172.16 255.255, and totally you will have 64 networks where you will have 1024 hosts per network. Do you understand this? Perfect. So go ahead, try this thing as slash, try this thing for slash 21, slash 20, and slash 18 and see if it works for you. Okay, consider the same network and see if it works. So I'll solve the assignment questions for you as well. Where let's see. Yeah, I'm gonna explain that. Don't worry. So let's try slash 21 again. When we tried for slash 21, you can see, let's say 172.16.0.0 slash 21 is what we are trying. And the first thing first, what we will be doing, we will try to convert this into binary. So the 16 bits for class B is going to be same, right? So we say 8 ones, next 8 ones, and then as we are solving it for slash 21, we will have extra 5 ones that will be acting as borrowed ones. So we'll say 1, 2, 3, 4, 5, and then we say 0, 0, 0, or that 0, 0, 0 actually is going to be host portion, and then we say rest of 8 bits is going to be host itself. Make sense? Now if we figure out the number of networks, then the number of hosts, then subnet mask, and ranges for the same. Then the number of networks will be 2 to the power 5 because we have 5 borrowed bits, right? And that will be 2 to the power 32. Oh, sorry. The answer will be 32 there. 2 to the power 5 is 32. And then the host will be 3 this bits and 8 from the last octet. So we say 2 to the power 11 there. That will actually be 2048. And then the subnet mask for that will be 255.255 dot 248.0, because we need to add the first 5 digits from the master formula that we have. So when we have 128, 64, 32, 16, 8, 4, 2, and 1, as we have borrowed first 5 bits here, we will be adding up first 5 bits, and the addition of that is 248. So that's exactly what we will write down in the third octet. And then when we figure out ranges, we need to first make sure that what's going to be the number of segments there. So we say divide it by 256, and that actually becomes, when you divide it by 256, then the value becomes 8 there. You get that? So this is going to be the number of segment. Now the range will actually start from 172.16.0.0 and it will end up at 172.16.7.255, and then 172.16.8.0 to 172.16.15.255. That's going to be next segment. Then 172.16.16.0 and 172.16.23.255, and till we will go to the last network, that's going to be 172.16.249.0. 255.255. Like this, these will be 32 networks, and each network will have each network will have 2048 hosts per network. Do you understand this? We divide it by 256 to get the able to figure out that how many number of segments do we actually need to merge into one of the network. You see, we are actually over here, we are starting from 0 and we are ending at 7. It means that 0, 1, 2, 3, 4, 5, 6, and 7. These are the 8, I would say, segments. And each segment contains 256 IPs. So when we multiply it by 8, then we get the result as 2048. So when we segment or when we merge 8 such segments of 256 IPs, then we get one network of 2048. The range limit is calculated in a way that the number of segment decides how many segments do you need to merge. So you go from 0 to 7, that is 8 bits, then next 8 to next 8, then 16 to 23. I'm just adding 8 segments per network. And the IP for the last octet will start from 0 and it will end up at 255 every time. Okay. And what I'm doing over here for the last one, so if you figure out that the last network is of course going to end up at 255 every time. Now when I'm figuring out that 8 is the number of segment that I can have at max in order to have 2048 as number of IP address per network, then I figure out the last network, that is 255 or 255. And what do? I just subtract 8 from that. So I know that we start at 249.0 and then we end up at 255 or 255. The second last network for the same will be in a way that you start at 172.16.240. Okay, this will of course, yeah, this will be 248.0. So we start at 240.0 and we end up at 172.16.247.255. That's how you add 8 different networks there. Makes sense. This is pretty easy. You'll need to practice this, and when you practice it a lot, then you'll figure out by yourself that what I'm talking about. Next, let's talk about /20 here. That if I come down with the same example for /20, then what will happen in /20 is I'll change this thing to, and then what will happen? The number of hosts or the number of borrowed bits will change to only 4 now. Now, how would you figure out the thing? Number of networks will be 2 to the power 4 there, which is going to be 16 network, and number of hosts will be 2 to the power 12 now, which is going to be 4096. And then subnet mask will be 255.255.240.0. And then when you come out to figure out the range, now it's of course gonna start from 172.16.0.0, right? Can I go and say 172.16.0.4095? I cannot do that, right? So for the same thing, what I'm gonna do, I'm gonna figure out that how many blocks of 256 can I merge to get one big network that can consist 4,000 IP addresses. And that's exactly why I divide these segments. So I say divide it by 256, and then I say the number will be for me, that is going to be 16. So then I get to figure out that if I start at 0.0 in a way that 172.16.0.0, then I can end up at 172.16. You just need to go till 15. So 0 2, I cannot go to 16. This will total be 17. So I say 0.15 there, dot 255. And then the second network will start at 172.16 dot 16.0, and we say 172.16.31.255, and then I say 32.0 to 47.255, and 48.0 to 63.255. Like that, I will have the last network as 240.0 to 255.255, like 172.16.255.255. Do you understand that? Excuse me. Yeah. Do you get that, guys? It is actually similar to class C itself, but the only thing that is different is the modifications are happening in class in third octet instead of the last octet. That's the only thing that you have. Make sense? I'll request you to practice for everything that is possible there. Like when you talk about class C, then I would request you to please practice for slash 25 to slash 30. When we talk about class B, do practice it for slash 17 to slash 23. And more you practice, the better you will understand how this is actually working. It is pretty the only thing that you need to practice there. And once, like, the more we practice, the more you get there. Cool. After discussing this, what we are going to do, yeah, the actual number of hosts will be then less than 2. So when you have 4096 as the number of hosts, the usable number of hosts is of course going to be 4094 there, like an odometer. Exactly. Yeah. So now we are going to discuss about how class A subnetting can be done. More complex now. So when we talk about class A subnetting, then we will practice. Now class A subnetting spans from /8 to /15. Okay, and we will try /15 first. So I'll take an IP from class A, that is 10, and I'll say 10.0.0.0 /15 is what we are trying, where we only have the network prefix as the first one and every other thing is host prefix. You get that? So when I try to, I would say, write down the binary of this /15, it looks like this. The first 8 bit will be constant. These 8 bits are going to be constant. Then the next 7 bits is something that we are actually borrowing. And that is 1, 2, 3, 4, 5, 6, 7, right? This is something that I'm borrowing. And then after that, the 8th bit into the second octet will be the host prefix. And then everything after that is going to be host. Correct? So based on this information, if we figure out the number of network, number of host, subnet mask, and ranges, then you can say that number of network is 2 to the power 7 there, which is, I would say, 128 again. And then number of network, what that would be? Number of network is going to be now 2 to the power 17. Do you understand that? And what's the value for 2 to the power 17? It's 131,072. And then if you figure out the subnet mask for that, it's 255.254.0.0, 8 bits and 7 bits slash 15. You get that? And then we come down to ranges. Now here's the thing. Of course, we're going to start at 10.0.0.0, but we also need to figure out the number of segments here as well. So if I divide this value by 256, which is 1,31,072 or 131,072, then the output that I get is 512. Correct me if I'm wrong. And you can see that the value over here is still not less than 256. So what do we do now? Because as we go according to the logic, you need to divide the value by 256 until you get it down less than 256. So how do you do that? You do that by further dividing that particular value again by 256, and then the output will be 2. Make sense? No, no. You don't need to divide it by 512. You need to divide it twice by 252 to 256. And then the output is 2 over here. Now here's the thing. When we were not dividing anything, the changes that we used to do was into the last octet, that is class C, right? When we used to divide it for once in class B, the modification used to happen in third octet. And now that we are doing the changes for twice, the modification now shift over here to the second octet where we can actually play there. Make sense? So how is it going to work? The thing is going to start at 10.0.0.0 and it is going to end at 10.1.255.255. And this entire network contains 131,072 IP addresses in it. Makes sense? Because this entire three last octets are dedicated for host IDs. Cool. I hope you understand that. So just like that, what we are going to do, we'll write down the next block, and that next network is going to be 10.2.0.0, and it will end up at 10.3.255.255. And then you will have 10.4.0.0, which will end up at 10.5.255.255, and then 10.6.0.0 to 10.7.255.255. Like that, the last network will be 10.254.0.0 to 10. All 255. Makes sense? And this entire thing will be 128 networks. Each network will have 131,072 IPs. Do you understand that? So I request you to please try your hands on slash 14 slash 12 slash 11 and slash 10. See if these four things works for you, considering the same IP address there, 10.0.0.0. Okay, you can write down the first four and one last network there, not the everything, but see if it works for you. That how the calculation actually needs to be done. So let's say for 14, when we talk about that, if you do the scenario for slash instead of 15, let's say we are going to do it for slash 14. So in that case, you would see the number of network is going to be 2 to the power 6, right? And the number of host will be 2 to the power 18. It will increase there. Make sense? And that's gonna give you a value, which would of course be 262,144. And when you divide it by 256, you're going to get a value that is 1024. That's why you again need to divide it. And then you get 4 as the answer. And that's the number of segments that you will merge. So the host will be somewhat around. Okay, I made kind of a mistake there, where 2 to the power 18 actually needs to be number of hosts. So I'll put it over here. There you go. And then number of network is 64. Yeah, I'll put that on charge, don't worry. Then the subnet mask, when we look at that, you say 255.255.2 sorry 252.0.0, and then after that the ranges will be something like 10.0.0.0, and then you will end up at 10.3.255.255. The next network will be 10.4.0.0 to 10.7.255.255. And just like that, 10.8.0.0 to 10.11.255.255. Like that, you will reach out to 10.252.0.0 to 10.255.55. Like that, you will have such 64 networks. And each network will have 262,144 IP address per network. Make sense? Do you guys understand this? Perfect. So I believe most of you can practice the same over here. And then now we'll move on to the next thing. So see, whenever this was about subnetting, okay? Now we are going to move on with the next thing, where we will now start discussing more about networks and how you can actually configure them. But before that, you need to understand that how these characteristics actually work there. Yeah, you need more practice in there. Now I told you that there are different type of networks that are present, right? So when we discuss about some of the things, that what are type of communications, or yeah, what are medium of communication that we have seen so far. So we discussed that there can be unicast, there can be multicast, and there can be something called broadcast. But this unicast, multicast, and broadcast actually works when you discuss about when the communication happens. So we are on a verge in order to understand what are the different type of devices that you have and some of the common terminologies that are associated with those terms. Make sense? Now pay your attention here. Usually, when I say that I want to connect two different networks together, or two different, I want to make a common network. So what do? You basically take a couple of computers and you connect them by using Ethernet cable, I can say. And usually this Ethernet cable will be something called Cat5 Express, okay, or it can be Cat6. These are two type of models of the cables that you actually use. And when you connect these, I would say, cables together, then it actually depends on the network interface card that is installed over here as well onto each and every computer. So you will have a network interface card, and that network interface card will have a connector called RJ45. Okay, every network interface card has something called RJ45, and you can Google what's RJ45. You will get to know about it. It's basically the port in which actually we plug our, I would say, Ethernet cable into, right? And we use that cable in order to do all sorts of communication, the basic communication that we do. Cool. Now, what would you do when I say that my requirement is not there to just connect two of these pieces together? My requirement is to connect multiple pieces together there. You get that? And how do we do that? We basically use some of the centralized device. And how do we do that? Let's say you have four PCs. You have this PC, then you have some other PC over here, and some other PC over here, and some other PC over here as well. If you want to communicate or if you want to connect both all of these PCs there, then you need to use help of centralized device. And this centralized device in the early age of internet was something called hub. And what would you do when you connect these devices with the centralized device called hub? Then let's say that you want to send your traffic from PC number A to PC number D. So I'll name these PCs as well as A, B, C, and D. And when you do this type of communication, let's say these PCs also have some of the addressing that are configured on them. So PCA has an IP address 192.168.1.1. PCB has an IP address 192.168.1.2. PCC has an IP address called 192.168.1.3. And PCD has an IP address called 192.168.1.4. And it also has MAC address as 1111.2222.3333 and 4444. You get that? These are the addressing parameters. Now, when I say that the communication actually needs to be done from here to here, then your PC actually will collect some of the information. What that would be? It will collect the information about source IP. The source IP is going to be 1.1. Then it's going to collect the information about destination IP. It's going to be 1.4. It's going to say what is the source MAC address. That's going to be 1111. And what would be the destination MAC address? That's going to be 4444. You understand that? And when you have such type of configuration there, then what's going to happen is once your PC actually sends some traffic to this destination, then who's going to receive it? It will be received by the hub there. And how will hub act on it? Anyone can tell us that into the chat? How will hub react to it? Hub will do broadcasting. That's actually correct. And that is exactly why we call hub as the dump device. Why so? Because when hub kind of receives such kind of communication, which is coming from this PC, and it needs to go out on this PC, but instead of forwarding that particular thing, uh, I would say to the hub, what hub does? Hub forwards that particular traffic on this, and on this. Make sense? Except the port that the traffic was coming from, hub will forward the traffic to each and every port that is available there. Why so? Because hub doesn't have any sort of brains to process that particular frame or packet that is coming to it. You understand that? And for such reasons, we call hub as a dumb device. So when we review hub is called as a dumb device, and it cannot do unicasting or multicasting. It only does broadcasting. Make sense? It doesn't maintain any table, no information regarding the traffic. And then the most important characteristics, it works on half duplex. Okay. and shares collision domain. You get that? What these things means? It means that hub only has a single collision domain for each of its port for the entire ports or the range of ports that it maintains. For example, let's say that A initiated a traffic that needs to be sent out to D, and at the same time C also initiated a traffic that needs to be given to the B. What happens then? This will actually cause something called collision. Make sense? And then hub will kind of initiate a jam signal to each and every port there, and then no transfer will be allowed for the random amount of time. So hub will send a jam signal with some random timer, and until that particular timer expires, nobody will be able to send or initiate any transport back then. You get that? Why so? Because hub doesn't understand how full duplex traffic actually works, which means that hub only knows how to send and receive traffic one at a time. Meaning it can either send the traffic on a one port, or it can either receive the traffic on that particular port. And that's why we say that hub works on half duplex and it doesn't work on full duplex. So as there were multiple limitations that were actually available, then in the picture there comes switch, which acts as the successor of hub. So if we replace this picture, or if we replace this centralized device with something called switch, and switch has then all these different four ports that are connected, then would switch be able to communicate with all the other connected devices by using other type of mediums, be it unicasting, multicasting, or broadcasting, and would it be able to share some data according to the requirement? Of course, yes, right? Exactly. And that is where we use hub for the layer 2 device. And why do we call it as a layer 2 device? Because it works with the help of something called MAC addressing. Make sense? So if we talk about switch, then switch has certain characteristics as well. And where the first characteristic of switch specifies that it works on full duplex. Okay, then it has multiple collision domain. Okay, it supports, I would say, unicast, multicast, and broadcast. Exactly. If you want to understand what is collision domain, let's say, I'll give you an example. Let's say that you have something like this. For example, you have a classroom environment. And in that classroom environment, you see that there are around 10 people that are sitting in this classroom. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And these 10 people have just one entry and exit door. That's basically the door that you have. Now, if I give an instruction to all of these that are sitting into the class, if I say that, hey, everyone, please get up and get out of the class, then everyone will kind of gather over here. They will start walking off to the exit door, if I'm not wrong, right? And so does this device, this device, this device, this device, and this device will do. So what is going to happen over here? Over here, something will be called as collision. And that's exactly the same, I would say, concept there. But instead of doing such type of collision, what would happen if I just like reverse everything and I say that instead of having the main door, everybody now will have their own entry and exit point like this. So one will go with this way, two will go this way, three will go this way, four will go this way, five will go this, six, seven, eight, nine, and 10. Will there be any chances of any collision there? There cannot be any collision in this type of scenario. Do you agree that? Exactly. It's just like a phone call that you can listen and speak at the same time on the phone call because it works on the model of full duplex. Make sense? So that's how switch is different, and switch has various other characteristics as well. So we call a switch a layer 2 device. Now if I give you a scenario for the same, because that might come up in your exam. Let's say that you have this particular switch here, and this switch has different users. You have user A, you have user B, you have user C. How many collision domains will I have? Three collision domains, right? Now let's say that I basically connect another switch with this switch 2, and then I have this scenario like this, and that is D, E, F, and G. Now how many collision domains do I have? Exactly. You have 8 collision domains, which means this one, 2, 3, 4, 5, 6, 7, and 8. This common link between the switches will also be one of the collision domain there. So that's why totally you have 8 collision domains. Now let's say that with switch 1, there is a user or there is another device which is called as hub. And this hub also has different 4 users connected with it. Now how many collision domains do you actually have there? Perfect. You have 9 collision domains. Someone is saying 13. That is wrong. Why so? Because hub completely shares its entire collision domain will just be one collision domain. And that's how the scenario is going to be there. You get that? And that's how collision domains can be understood. Now, what is broadcast domain? Broadcast domain is something which is also referred to as layer 3 boundary. Okay, so when you have or when you get a router inside a network and then you connect multiple, I would say, switches with it. So if you have switch 1 there and switch 2 there, and both of these switches are somehow connected to the router. So how many collision domains do you have now in this scenario? Can I say 1, 2, 3, 4, 5, 6, 7, and 8? You have 8 collision domains there, and you just have one broadcast domain. Makes sense? You have 8 collision domains and you have one broadcast domain there. Now, if I say that I do not connect this particular switch over here, and instead of that, I make a connection of this switch directly with the router. Now, how many collision domains do you have? And how many broadcast domains do you have? Exactly. You have 8 collision domains and you have 2 broadcast domains. So when we figure that out, we come to a conclusion that if we talk about switch, then switch has one collision domain per port. And if we talk about broadcast domain, then switch have one broadcast domain per switch. Okay, per device I'm talking about. And if we talk about router, then one collision domain and one broadcast domain per port. That's what the difference is between the router and between the switch. You understand that? So this is how collision domains and this is how broadcast domains actually work. Now what we are going to do, we are just going to build up, uh, I would say, a common topology, and we are going to configure a common topology and see how the communication can actually be done here. So the thing that we are going to use is Cisco packet tracer. We are going to use this Cisco packet tracer in order to do all our labs that we will be doing in this training. Okay, so give me just 2 minutes and I will share the software with you. If you don't have this, you can, some of you might have downloaded it from the internet as well. But I will put that particular thing for you guys on my drive link, and I will share the drive link with you in just 2 minutes. And then I'll tell you how you can install it, and then we will see how you can, I would say, use it. Any version after 5.3 will work for us. There is no limitation of what version do you actually want to install. I'll put the latest one there. Thank you. Cool. This is Cisco Packet Tracer that we are going to use, and I hope everybody will be familiar with that soon. There is no credential that needs to be used. When you are being prompted for the credentials, you can see at the lower right side bottom corner, there is a button for guest login. So you can click on that guest login, and there you will need to probably wait for 15 seconds, and after that you will be able to continue that. Okay. While it gets downloaded for some of you, while you are in the process of installation or so, what we will do, I will try to introduce you guys with the overview of how this software actually works and the architecture of it. So you can see that there are different options that are available. I've shared my computer screen and I believe almost everyone can see that. If you're not able to see the screen, you can drop the session and join back again. And so these are the different options. Okay, you can see that this is basically, I would say, the main toolbar, the main menu option where you have file option. You can click create a new file here. You can open up a new file. You can save your project. You can print your topology. You can get some information and so on. So this is copy, paste, undo, redo, zoom in, zoom out, zoom reset, and some of the coloring options or so. Okay. We won't be playing with much of it. Then after that, you can see this is the toolbar that we use. So this toolbar is for selecting the device. This is for zooming in the topology or inspecting something. This is to delete some of the objects of the topology. Then you have, I would say, to select a specific thing from the topology. Then you have around, like, if you want to make any notes, you can select this option. If you want to draw some of the designs there, then be it rectangle, square, or so, in order to organize the topology, you can use these. And these two tools are basically used in order to simulate a traffic flow. So this is kind of an ICMP traffic. You can select these messages and you can use them in order to send from one device to other device. Make sense? Then, if you see this empty area over here, this is actually where we build up our topology. Okay, this empty area is where we will be creating our topology there. And then at the bottom corner, these are different sets of devices. So you have two different columns. One is this row, which actually gives you different view of different devices. So the first row indicates different category of devices, and every category will have different types of devices, and every type will have different models in it. So category, types, and model. These are the three options that you have here. If we look at the first row, the first category is network devices. And then the type of devices that we have are routers, switches, for hubs, wireless devices, security devices, WAN emulation devices, and so on. If I click on the routers, then on the next column, I will see different type of router that are available with us. Make sense? If I see a click on switch there, then these will be the different type of switches that you have here. If I check the hubs, these are the hubs that you have. If I check at the, I would say, wireless devices, these are different wireless devices that you have. Make sense? Just like that, these are the different categories of these. Yeah, the devices that you will see will only be of Cisco, as it's a Cisco packet tracer, and there won't be any devices from any other vendor. Then, if you click on some other type of device, let's say end devices, when you click on that, then you see the end device section over here. Then you have home devices, smart city devices, industrial devices, and power grid devices. So in the end device section itself, you will be able to see there's a PC, there's a laptop, a server, a Meraki server, printer, IP phone, VoIP device, normal phone, television, wireless tablet, so on, so on, so. Okay. And then you can see that on the home over here, you will find your IoT AC, your appliance, your battery, your Bluetooth speaker, or your carbon dioxide detector, or so on. So, but the only devices that we'll be working with usually be routers, switches, and I would say PCs also. So in order to build up a topology, what you need to do, you need to click on the first section, which is network devices. Then you go to the, I would say, router section. And from the router section, remember this thing, you will always be using a device that is called as PT router. Okay, we will be using a device that is called as PT router. Makes sense? We won't be using any other router because PT router gives us enough numbers of, I would say, interfaces that we'll be requiring. So we are going to use PT router because it has all the default settings of the number of interfaces that we need. Other devices will be needed to modify, and some of the commands will not be supporting over there also. So this is a standard router that we use for all type of configuration. Now, once you see the device that you need to use, then you can click on it and drag it up like this onto the workspace, and you can leave it like that. And then your router will be pasted over there into the topology or into the workspace. Then I'll do that again. When you want to delete it, you can actually select it, or you can actually select it like this, and then you can click on delete. So when you click on delete here, there you go, it's done. And then you come back to the selection method like this. When you are over here, you select a device and you drag it up into the working topology, and then that's how you like get a device there. The next option or the next device that we are going to work with is going to be a layer 2 device, which is a switch. So from the network devices section, we'll select, I would say, a switch now. And when I click on switch, then these are different switches that we have. We will always be working, here's the thing, we will always be working with a switch that is 2960 here. Make sense? So I'm going to put that particular file over there, which is a 2960 series switch. And then I would say after that, what we are going to do after putting a switch there, which is 2960, which is the first switch in the category, then you can actually select the end devices section. And in that end devices section, you select the PC from here or the laptop, whatever you choose. So you can click and put up multiple PCs. I'll put a PC there and I'll put a laptop there. These are the two devices that we will have. You get that? And then after that, yeah, these devices are still used. Okay. And then after that, you can say that you click on the device or you click on something that is called as connections. And then you can see that if I click on the connections button, then there will be multiple type of cables that you can see here. Okay, there is a cable called automatic, there is a cable called console cable, copper straight through cable, copper crossover cable, and so on, so on. So fiber and every other thing. The cable that we will be using in order to connect any device is automatically choose connection type, the first one. So we click on this particular automatically choose connection type. And then once you select the cable, you can see my cursor has changed to something else. And then after that, you basically click on over here on the router, there you drag it up, and then you connect it with the switch there, like that. Then just like that, you click over here, again select the cable, click on the device, drag it up, and click on the destination device. Make sense? And just like that, you select the cable again, click on the device, drag, and again click that. Do you understand how the cable connection is done? However, there are different cables as well. Okay, and most of you might be confused between why are we using automatic and not the straight through and so. We'll be discussing about different cables that we have later in the coming sections, but as of now just use this automatically choose connection cable. So that's how we work with it. Makes sense? And the network that we're going to configure for ourselves is something called as, so you can create a note over here. I'll select a note and then I'll put it over here in a way that 192.168.1.0/24. This is going to be the network that we're going to configure for ourselves. Do you understand it? The cable name that we are actually using is automatically choose connection type. I'll again try to create this image. I've selected the entire image, I'll delete it. And then after deleting it, what I'll do, I'll go into the router section, which is the network devices. When I go to network device section, I select the routers, which is the first device. And then after that, these are the different devices or routers that we have. So what we select PT router. And then I drag this particular PT router here. And then after that, we select another device. So after selecting the router, then I go to the switch section, which is the second one. And then after that, I select a device which is 2960 and I drag it there. And just like that, I will go into the end device section, which is the second one. So I click on this end device section and then I select this end devices and drag a PC there and drag a laptop there. And once you have your devices ready, then I can actually go to the cable type, select the cable, and then I can automatically choose connection type and say router with switch. And then after that, switch with PC and switch with laptop. That's how we do the connections there. Now we'll kind of see how the communication actually works between two of the devices. And when we look at it, then what we need to do is first we will only be configuring the thing that is like PCs. So as of now, there is no communication between the devices that you have. And what we will be doing is we'll be working with, I would say, a switch there. And let's say I have a switch here. And then inside of that switch, you have different PCs. So I'll take around 4 PCs here. And when I say that I have a switch in between, then I can connect these switches with the PCs. And then after that, yeah, guys, so you can connect your switches or your PCs with the switch that you have. And you can see once I connect these cable, then at that time the interface is red. It means that the interface is coming up to green. Okay, so it takes some time for a switch to turn on a specific interface there. And if I go and configure like some IP addresses there, now we are using a network that is 192.168.1.0/24, in which the range of IP address would be 192.168.1.0 to 192.168.1.255. But as you know, 1.0 will be your network ID, okay, and 1.255 will be your broadcast ID. Makes sense? So the available or the usable IP range is something called 192.168.1.1 to 192.168.1.254. Out of that, we'll assign 1.1 to the first PC, 1.2 here, 1.3, and 1.4 like that. So in order to assign IP addresses to something, let's say, in order to assign IP address to the PC, you can click on this PC and then you can select the desktop section from this particular window. And then after that, you can click on IP configuration. I'll again do that. Click on the PC, then click on desktop, and then click on IP configuration. And then you go into static and then configure 192.168.1.1. And then when you press tab, then it will automatically configure the subnet mask here. Make sense? Then that's the only thing that you need to configure as of now. Then you close this window, go to the second PC, then configure desktop, and then IP configuration. And then over here you say 192.168.1.2, and then give a tab there, and then close it down. And then go to the third PC, go desktop, IP configuration, and say 192.168.1.3 there, and then tab. Or I believe I have configured, yeah. And then go to the fourth one, go to desktop, IP configuration, and say 192.168.1.4 and tab, and you close it down. Like that, you basically do the configuration of these computers. And then once your configuration is done, then in order to check whether the communication is happening or not, what you can do, you can actually select this particular message here that you can see. Okay, you select this message, and from here, when you select it, you can see a message has been selected. And then you click on the source PC, and then you go and click on the destination PC, and then you click here. So once you do this communication on the right side, lower bottom corner, you can see that the communication between PC2 and PC5 has been successful. This is my PC2, this is my PC5. Okay, so the communication between that is successful. So I'll do that again there. That so what you need to do after you design the IP, you design the network there. Then you click on the PC, and then you go to the desktop section and go to the IP configuration. And then after that, you configure IP address, type down IP and subnet mask here. So when you type down IP and click on subnet mask section, it will automatically detect that. There's no issue to detect that thing. Get that? And then you close it up. Then you click on the other PC, IP config and configure it. So we are providing 1.1 here. Then we are providing 1.2 here. Then we're providing 1.3 here and 1.4 here. That's how we are basically provisioning the IP configurations. Makes sense? Do you understand that? And then when you're done configuring the IPs, then you can select a message from here, which is this. Select it, then click on the source button and click on the destination. And that's how you basically check from PC2 to PC4 the communication was successful. So this is exactly how you check whether the communication between your PCs are working or not. Do you understand it? Go ahead, try this thing and see if it works for you. There is no IP address that has been given to the switch. Switch doesn't work with any of the IPs. Switch is a layer 2 device and it doesn't configure or it doesn't work with any of the IP. It is just connecting you guys together or it is just connecting the PCs together. How to check the connection is successful can be checked by sending the message. Select a message from here and click on the PC, click on this destination, and over here. This is how it shows that it is successful. What is 802.11? It won't ask you for any of this. If you don't see the message box on the right side, it might be shrink down like this. So if your window is like this, you will see an arrow over here, right at my cursor, where that is. So you can click on this arrow and the tray will come up where you can actually check your scenario. So I hope you understand that. This is where you see the message. If you want to send a message, you click over here. Your subnet mask will automatically come up if you are working, if you are configuring it. That's how you check if your message is successful or not. When you're done, and if your window is full, you can just directly click on this delete option, and your window of your messages can go like that. All right. I hope you understand the concept of how you kind of access the things and so. So what you can do now is you can play around with this software a bit. And I would say that was basically all that we had to discuss in this class. We're going pretty with a good pace there. Where the next section is we will be starting discussing about the operating system of Cisco and how it works. Then we will discuss about different ports that we have when we will work with router. I'll tell you about Ethernet, fast Ethernet, gigabit Ethernet, then different cables straight through crossover fiber and how they actually work. Okay, we'll talk about then with routing, how you can implement routing, static routing, dynamic routing, and so on. So all those concepts are coming up in line for you. So don't worry about the amount of topics that are going to be covered. I'll tell you enough of the topics that I can cover. Okay. The lab assignment can be the same. I request you to play around, design different topologies for you guys. Okay, and see how it works for you. Yeah. So the purpose for this particular class is always good. And thank you for all your patience.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Yeah. So we're going to discuss in this session about how you can configure your networks by using different mechanisms. I hope we discussed about class C, class B, and class A subnetting, and I made you familiar on how you can like use packet tracer. So the software that you're gonna use inside of this training is going to be Cisco Packet Tracer. Let me share my screen quickly. And there you go. I hope you all can see my screen. And I'm gonna start a software which is Cisco Packet Tracer itself. There you go. Now, in this software that you can see, I'll give you a quick, I would say, overview of how the software actually works. And I believe I told you the same in the last session as well. But we have this main toolbar over here, which is kind of something that gives you an ability to select a topology, to delete some object from that topology, be it router switches or something, in order to delete something, and in order to design anything according to your topology requirements. Okay, so that's kind of a main toolbar that you have here, and then you have like a menu option, which is about creating a new topology, opening up a new topology, saving a topology, printing a topology, right? And then we have copy paste options, we have undo redo options, zoom in, zoom out options, and we have some other options over here. But the main section, or but the main function that you need to like make yourself comfortable with is this over here. So these blocks here kind of ensure something, that the first row is I would say the like various type of network devices. So you have network devices, you have end devices, you have components of them, you have cabling standards, then you have some miscellaneous devices and some WAN devices. And if you click on some or the other type, then the second row changes accordingly. So if I click on network devices, these are the type of network devices that you have. You have a router, you have a switch, you have devices like these. And when I select a router, then in the next column, these are various, I would say, options that we have in order to choose, or in order to see that how like what are the routers models that are available. And then if we click on switch, then you can see that switch as well has various models over here, right? Just like that. Then this particular section over here might be hidden. Okay, so this might be whenever you install the packet tracer by default, then this might be the scenario that you would see. And you will not see, I would say, a result window. So you need to enlarge that particular window by clicking on this arrow button over here at the very corner. So when you click it, then you will see your result window, where whenever you transfer some traffic, then you see the output whether the traffic went successful or not over here in this window. And this is how the dashboard over here looks like. This empty area, the white space that you see here, is nothing but the topology area. So we're going to build our topology over here itself. Now, I told you about how you can like use the basic topology. And when I say that if I take a router and a switch and try to build up a network, then here you go. So I can go to the network devices section, then I can go to the router section. And from this router section, I kind of drag out. Yeah, I hope I become more audible like this way. So if you want to create a topology there, then in that topology, you can say that the router that you need to select from this list is PT router. Okay, this PT router over here. And we use this PT router because we have enough number of interfaces that is built in into this PT router. And the way that we need to select it, it's just by dragging it over here. So you can drag this particular router like this. And if you want to delete it, you can just click on this particular delete button, and it will ask you, do you want to delete the selected item? Say yes, and the router is no longer available there. And then you can press an escape button to get out of that particular delete mode. And then if you want to put it again, then you can say PT router can actually be placed over here. Make sense? Now, just like that, we also want some devices, let's say a switch. So a switch can be selected by going into the switches section here. And then when you click on that, you can drag this 2960 series switch, okay, over here into the topology. And just like that, you can also drag some other devices, be it end devices. So with the switch, we want to connect around different PCs together. And when you say click on end devices and then click on PC, and you can drag these PC over here, and you can drag the laptop over here as well, like that. And once you have certain devices ready, even like more PC or so, then what you can do is you can actually, I would say, connect all these devices together by selecting a cable. Okay, so when you select a cable, now here's the thing. We have different types of cables that are available. And if I talk about Ethernet standards that you have, then you can say Ethernet standards. The first Ethernet standard that you have is Ethernet itself. And whenever you have Ethernet ports or Ethernet, then the speed of that particular Ethernet port is 10 Mbps. Cool. Then the second, I would say, type of standard that you have is fast Ethernet, and the speed of that fast Ethernet is 100 Mbps. Okay. And third, you have gigabit Ethernet, and the speed of that gigabit Ethernet is 1 Gbps. And if you talk about the fourth one, then you have 10 gig Ethernet. And of course, you might have guessed the speed of that is uh, Gbps. Okay, it's megabit, not byte. I've written the small b, right? So it's megabit. And if we talk about the cables, then there are different type of cables that are available. One is copper cable, and the other one is, I would say, fiber cable in order to send. And copper also has certain standards into it. So copper, you can say STP, which is shielded twisted pair cable, and you have UTP, which is unshielded twisted pair cable. And if you want to check that, you can open up your browser, and you can see that as well over here, unshielded twisted pair cable. And this unshielded twisted pair cable looks like this. So this is kind of a cat 5 or cat 6 cable, which is actually something like this. So you will have 8 different pins over here having different colors. Okay, you will have green, white, and green, brown, white, and brown, orange, white, and orange, and then you will have blue, white, and blue. Okay, so you twist them together so that there, I would say, electromagnetic interference when the data actually travels from those cables doesn't like create like collision with the other data that's also traveling over there. Okay. And then if we look at the shield, like the comparison between shielded and unshielded, so this is how the comparison looks like. The shielded twisted pair cable is like has a I would say a shield of aluminum foil around the pins that are there. The number of pins and every other thing is just same, but the only difference over here is it will be shielded. And why it would be shielded? Because there are two ways, or there are two platforms or infrastructure we actually need to use these cables in. We need to use it outside our buildings or whatever infrastructure you have. Whenever an ISP gives you a cable, then ISP needs to carry that particular cable and lay it over the city to make it reach out to you for providing you the broadband connection, right? And that particular cable that the ISP uses is actually called a shielded twisted pair cable. But the other cable that you use inside of the infrastructure, be it in a building, be it in a lab, or be it in any environment, we call that particular thing as unshielded twisted pair cable. So the shielded twisted pair is used in a scenario when you actually need to like shield it from the atmospheric challenges. Okay, be it summer, be it winter, be it rain, it will face all those things. But the unshielded twisted pair cable is not that strong. That's why we use it in home environments or office environments. Okay, and this is expensive one. So even when you use this shielded twisted pair cable or unshielded twisted pair cable, there are even types in that. So and the other one is of course fiber. So if I show you the optical fiber cable, and you can see that this is how the optic fiber looks like, right? So you'll have kind of an optic fiber cable, and then this particular optic fiber will actually have a core where the data travels with the speed of light. That's why whenever you're talking about a pretty fast internet, you need to go for the fiber optic cable, because that is something that provides you the faster data over there. Makes sense. And if we look at like the types of copper cables that you have, then you can create something in a way that is called as straight through cable, straight through copper cable. And the other option that you have is crossover copper cable. So if you look at straight through copper cable, we use this straight through copper cable in different devices. And when we have, I would say, crossover cable is basically used between same devices, which means is if you have router at the one end, and like if you have switch over here and one switch over here as well, let's say like this scenario, and if you want to connect both of these together, switch 1 and switch B, then the cable type that I'm going to use is going to be crossover. But if I want to connect this particular switch with the PCs or with the router, then I'll be using I would say straight through cable. So that is a rule over there because of some connectivity things that it needs. Because when we look at the copper cable, then the Ethernet segment only uses 4 pins out of the 8 pins available in a copper cable, and out of which 2 pins are used for forwarding and 2 pins are used for receiving the data. And same is happened, or same works over here with the fast Ethernet as well. Only 4 pins are used. But if you talk about the gigabit Ethernet, then gigabit Ethernet uses 8 pins. All the pins will be used for sending and receiving the data. And in the 10 gig as well, it will use all the 8 pins from the copper cable in order to send or receive that particular data from one location to other location. Okay, but in Ethernet and fast Ethernet standard, only 4 pins are used for sending the data, and other 4 pins are used for voltage supply. But in gigabit and 10 gigabit Ethernet, all the pins will be able to send the data as well, and they will be able to give the voltage supply as well over there. Makes sense. Then, okay, if you're facing some issue into the, I will share my screen again, don't worry. And there you go. I've shared my screen again, and I hope you all can see my screen now. So that's exactly what we were discussing about, that how Ethernet standards are created, how the cables are. And the only logic that you need to put up or understand is whenever you are using same devices, the cable type will be crossover. But whenever you're using different devices, the cable type will be straight through. But this is now old stuff. There is something called auto MDX. Okay, auto MDX. Now, what is this auto MDX? This auto MDX is basically a feature that almost every device now has it turned on. And the requirement of this particular feature is the duplex setting needs to be auto, and the speed setting of the interface also needs to be auto. Make sense? Now, when these settings are set up and your auto MDX on the device is on, which is by default on most of the devices, then you don't need to worry about the straight through cable or crossover cable, because it will be automatically identified. You get that? So then you can use any type of cable in order to connect from one device to other device, be it straight through and be it crossover. If you connect a straight through device in a desired crossover scenario, then the cable will behave as a crossover. Okay, if you connect a crossover cable in a straight through desired manner or straight through desired type, then it will automatically use straight through over there. So you don't need to worry about that which type of cable actually needs to be used for what kind of scenario. It is automatically taken care by with a feature called auto MDIX. Then after that, so we over here, as we have our topology with us ready, then in this particular topology, what we are going to do is we are going to connect all these devices by going into this connections window. And inside of this connection window, yeah, if you are connecting a PC with a router, then you can use crossover cable. Of course, you can use crossover cable, but you can use straight through as well. There is no need to be specific about these things in today's world. It is automatically taken care by. Now over here, if I want to connect all these devices together, what I'm gonna do, I'm gonna click onto the first cable which says automatically choose connection type, and this is one of the cable that actually represents the feature of auto MDI. So I'm gonna select this cable, and then I'm gonna connect my R1 or my router with the switch like that, and I don't need to specify anything over there. Then what I can do, I can select another cable and say connect this and connect this like that. But you see, every time you need to connect some devices, you need to go into the uh, window over there and you need to select the cable. So there is a shortcut that you can use. Is you can press. I'll delete these cables as of now. And what you can do is you can press Control button on your keyboard and then you select this particular cable. And it happens with every devices. Let's say you want to place 10 routers over here. So if you do it one by one, you need to go onto the router section and then you need to place one device, then one another device, then another device like that. But instead of that, what you can do, you can just click Control onto your keyboard, and then after clicking Control, you can select this PT router. And once by clicking the control window, when you select this device, you can leave the control button and then just click for whatever amount of time that you want. And for the amount of time that you're going to press the enter button or the click, then for those many instances the devices will be placed over there. Make sense? Just like that, you can do the same thing with the connections as well. You can go onto the cables, you can press the control button, and then you select the cable. Then you leave the control button, and then click and click, click and click, click and click, and click and click, and then you press the escape button once you're done. Do you understand that? So this is how you actually make use of that particular shortcut. So that's exactly how we're gonna use it. Now the network that we're gonna create for this scenario, we can create a note of that by using this note utility. And I can say over here that the network that I want to create is 192.168.1.0/24. Now you see, when I'm saying over here that I want to use 192.168.1.0/24, it means that the range that I'm gonna have is gonna start from 192.168.1.0, and it's gonna end up at 192.168.1.255. And if I talk about subnet mask is going to be 255.255.255.0. You understand that? So when you have such scenario, you can see that the first IP address, of course, will be the network ID, and the last IP address, of course, is going to be the broadcast ID. Okay, so the usable range or the valid IP over here is going to be 192.168.1.1 to 192.168.1.254. That is what is going to be the usable range, and out of which we are going to assign the very first IP address to the FA0/0 interface of the router, which is 192.168.1.1. And switch will not get any IP address because it's a layer 2 device, so it doesn't require any IP address. It just works with the help of MAC addresses. And then the PCs will get the IP addresses, be it 1.3, 1.4, 1.5, accordingly whatever they're supposed to get. Make sense? Do you understand what I'm trying to say over here? Please respond into the chat. Perfect. All right, let's move ahead with the next thing then. That after having this IP address configured over here, how are we gonna do that? Now, can you see that the packet tracer represents two different type of topologies or two different type of analogies here, which says that the range over here, or the cable over here is red, it means that the connection is red. And then you can check that the switch and the PC's connection is green. Make sense to you? So when we have this scenario over here, it means that the interfaces that we are using between the router and the switch are turned off. And if you look at the interfaces that are there between the switch and the PC, the interfaces are green there, which means that the interfaces are up and they are ready to forward the traffic. Now here's the thing. For whatever devices, or for all the devices that we have here, all these devices of Cisco uses an operating system of Cisco, which is called as Cisco Internet Working Operating System, which we call it as iOS. It is not the iOS of Apple, but yeah, we also call it as iOS. So this Cisco iOS that is loaded onto the devices that we actually use. And these devices are managed by something called command line interpreter, okay, which we call it as CLI. So if I want to do anything on this particular device, I need to use Cisco's iOS, and we make use of the CLI commands, or command line interpreter, or command line interface. You can better call it interface. It's interface itself. Yeah, command line interface, in order to make any changes to your topology. You get that? Now, how do you make changes? Here's one thing. Whenever you kind of create a topology, then I would suggest you not to do the practical when I will be designing something. I would please request you to pay your attention, okay, to my explanation, because it won't be possible for me to repeat I would say, to repeat the concepts again and again. So I will give you enough time after my explanation to do the lab, like I have given you the time to perform subnetting practice during the class, and I'll be sitting there to solve your questions when I ask you the question. But if when I'm explaining you, if you are too busy in following my lab along the way, then you won't be able to understand the concept, and then you will be asking me the doubts that please repeat and so on. So okay, so when I explain you something, you put your packet tracer on hold and pay attention over here. And then once I get done with the lab, then I'll say, now this is the time that you do the lab, and then you do the lab. Okay. Till then, you make your notes. What I do, okay, you note down if you need anything to be noted down over there. This kind of helps me to keep the class in flow. Cool. Now you see, so when you are going to install your packet tracer, you might not, upon creating a topology like this, you might not be able to see the interface names that I see here, which is FA0/0, FA0/1, and all the other interface names here, right? So what you need to do is you need to go to the settings of your packet tracer by going into options and preferences. Over here, I have some different settings, but yeah, you might have an options window over here. And inside that options window in Windows machine, you can click on you can click on settings or preference. Over here, I'm going to preference like this, and then such window will open up. And once you open this window up, you need to make sure that always show port labels in logical workspace is checked. If this is unchecked, then if you say, like, if you close this thing, then you see I also won't be able to see the names of the interface that I'm using. So what you need to do, you need to go to the settings of your packet tracer by going into options and settings, and then you need to click on this always show port labels in logical workspace, and then you can close this particular thing down, and then you will again start seeing the interface names there. Cool. Yeah, options and preferences, and then always show port labels there. Thank you so much, Aman. And then so after you become like good with the topology design, then in order to get the command line interface of the device, you click on that particular router, and when you click on the router, you will be getting, I would say, a window like this. Over there will be certain tabs. You will have a physical window, you will have a config window, CLI window, and attributes window. So to do any modification onto the device, you need to click on the CLI window here, okay, which is command line interface. And once you click on the CLI window, there you go. You will start seeing the CLI here. Now here's the thing. When you actually look at the CLI, then the very first thing after the image boots up, it asks you that would you like to enter the initial configuration dialog. And what you say there, you say no there. And then once you say no here, it says press return to get started. So return means press enter key in order to get started over here. Now to get started, what you need to do is when you say that in the command line interface, you need to understand there are three modes. One, you have a user mode, okay, which is actually represented with a greater than sign, or you can just say yeah, greater than sign. Okay, for example, like this, R1 is going to be the name of your router and then greater than sign, and like this. Then the second mode that you have is enabled mode, and this enable mode is also called as user privilege mode or privilege executable mode or so. But usually we call it as enable mode. And this enable mode is going to be represented with a hashtag. For example, like this, the name of the router followed by a hashtag. And then the third type of representation or the third mode that you have is global config mode, global configuration mode. And this global config mode is represented with config in bracket with a hash. For example, like this, R1 and then in bracket config and then bracket complete and then hash, like this. So these are three different modes that you have inside your command line interface, okay, or inside your operating system. So when you have these three modes, what you need to do is you at the beginning you will be in user mode. Then in order to go into from user mode, you need to go to enable mode, and then from enable mode you need to go to global config mode. And if you want to come back again, you need to go from like global config to enable and then enable to user mode. This is how the hierarchy works. You cannot jump off directly from user to global config. It's not possible there. So when you have the CLI over here, it says press return to get started, right? And when I hit return there, then you see the name of the router followed by greater than. You can hit enter button for how many number of times that you want to hit. And then you can say, in order to go to the enable mode, you say enable and then hit enter. That's how simple it is. So to go from user mode into the enable mode, you need to go into the, just a minute. Yeah, so to go from user mode into the enable mode, you use a command that is called as enable. And then after that, in order to go from enable mode to global config mode, you use a command called configure terminal. And there you go. So you see how the mode and the representation changes with the name of the router here. So you say router greater than sign, and then you also have hit the enable command, and then the mode changes, and then you use the configure terminal command in order to go from enable to global config, and that's how the mode changes. Now you see, in user mode, we actually just use this user mode command for doing the the very basic troubleshooting. Okay, you will hardly be using the user mode in order to do anything into the CCNA class. But then after that, when you actually go to enable mode, this enable mode actually is used for verification and troubleshooting purposes. So you can use all these show commands, you can verify your routing tables, you can verify your VLAN tables, or your running configuration, or specific configuration, interface configuration, all these commands, or all the current configuration and the saved configuration can actually be checked into the enable mode because it supports set of show commands there. And then after that, you go into the configure terminal mode, which is actually used for deploying any type of configuration there. Make sense? So enable mode and global config mode is are the modes where we are going to play a lot. So after coming into the global configuration mode, you are free to do any kind of changes over here. The very first change that we want to do to our router is rename our router. And how do you rename that particular router? You rename the router by using a command called host name, and you give it a space, and then you specify the host name that you want to rename your router with. So let's say I rename that particular router with R1 underscore pynet. Okay, you cannot use spacebar for naming your router. You cannot use any you can say spaces between the different words that you're using for naming your router. Just like that, I have used R1 underscore pynet, not space pynet, and I hit enter, and you can see the name of that particular router has been changed. Do you understand what I'm talking about? Please respond. Perfect. So over here, after you kind of rename your router, then there is one thing that we need to do. So according to our topology that we have here, what we need to do is we need to, you see, there are multiple interfaces. So you can get the statistics of every device that you have by hovering the cursor over that device. So if I take my cursor over there, then you can see that on the statistic window, you can see that there are list of interfaces that we have. Then on the next column, you see the link status. On the next column of that, you see the IP address configuration and so. So when you have the list of interfaces, you see that it's fast Ethernet 0/0, you have fast Ethernet 1/0, serial 2/0, serial 3/0, and fast Ethernet 4 and 5. And every interface there by default is down, and there is no IP address that has been configured on those interfaces. So according to our topology that we have, we need to go into the FA0/0 interface, and we need to turn that interface up, which means we need to turn that interface on. And then after turning that on, we need to configure IP address on that interface. Make sense? And how do you do that? So you go into the global config mode of the router. You again click on that particular router to get the CLI access. And then as you are inside the global config mode of the router, you use something called interface command. So we say interface space, and then you give the name of that particular interface. Someone is saying, yeah, I'll try to do that. Yeah. So you say interface space FA0/0, or you can say fast Ethernet 0/0, right? Because there you go. Now here's one thing. If you want to be familiar with Cisco's operating system more and more, then there are helper utilities as well. Like how do you know, or how will you get to know that which commands can you actually use, or how do you come up with the syntax of that command? So Cisco introduces something to you called question marks. And if you are in any mode, you can actually make use of the question mark. You see, I was into global config mode, and then by using exit, I came out of that particular mode to the enable mode. Then I again used exit, and then from enable mode, I went completely out of that router into the user mode again. So when I say hit enter now, I'll be into the user mode. Now, I don't know what all are the commands that can actually be used on this user mode or in this user mode. So what do? If I want to get the list of all the commands that are supported in this mode, I will just use a question mark over here. Do you see that? So after I placed question mark, these are basically the list of commands that you can use in order to like do your work at the user mode. So you can use connect command, you can use the session number to resume, you can use open a terminal connection, you can disable, you can disconnect, enable, exit, log out, ping messages, resume, show messages, right? Show running system and SSH, telnet, terminal, and so on. So all these commands actually can be used from the user mode. The one that we need to use is enable, which actually turns on the privilege executable command. And then we say enable. Now we didn't even know, or we don't even know that what command does, like, is it a complete command, or do we need to use anything apart from that as well with that command? So in order to get to know that, you can again like type your command over there, give it a space, and then say question mark again. And once you say question mark, it also asks you that what is the enable level that you want to do. Otherwise, if you don't know that enable level, then you can go in, you can like also hit the enter button. And CR is what indicates that there is nothing. It's fine if you don't enter anything after that, you can just hit enter. Okay, so I'll say enable and then hit enter. And then after hitting enter, enable levels is nothing something that you need to know about as of now. So just consider it as you can hit enter after that. And then when you click question mark again, then this question mark is going to give you the list of all the executable mode commands, which means the commands that can actually be used in this mode, which is auto, clear, clock, configure, connect, copy, debug, delete, dir, disable, disconnect, enable, and every other thing. Make sense? So that's how you can get to know about the commands that you need to use. And then after that, I say, like you see, I need to go to the config mode, so enter configuration mode. So I will use over here configure, and then I don't know what do I need to use after that. So it says terminal. So I'll say configure terminal, hit enter, and there you go. You are inside the global config mode. Now here also, if I don't know anything about the list of commands that you need to use, I can use question mark, and then you're gonna get all the configure commands that are gonna be here. And as we need to do the interface configuration, you can see select an interface to configure. So I'm gonna specify here interface. Now here's another thing. If you type down the command partially and you don't know the spelling, you don't know what do you actually need to type here, then you can just simply press tab button, and then this tab will automatically complete the command for you. This is how Cisco's operating system kind of helps you. But this will only work only if and if like there is only one command that you can use which starts with int. Like there is no ambiguity with this particular command, right? Int, because there is only one command that starts with int. But if I say, let's say if I just say I and then press tab, you see nothing happens, because there are multiple commands that are available which starts with I, and the device is not able to understand which I or which command are you referring to with by just using I. So you just need to complete that particular command, and as I say IN and press tab, it automatically said interface. Make sense? Do you understand what I'm trying to say? Perfect. Then after interface, what command would you use there? So you can give a question mark here as well, and it will give you an option that you can use interface dialer, Ethernet, fast Ethernet, gigabit Ethernet, loopback serial, virtual template range, and so. So the one that we need to use is fast Ethernet, as we are looking forward to go into this interface. So we say interface FA0/0, right? And after you go into the interface, you see the mode of that particular router change. And then over here, you can see that after FA0/0, then you say, in order to turn the interface on, you need to use a command called no shutdown. And as soon as you hit enter button over here by using no shutdown, then you will see some log changes, and then you will see the interface became green now. And you can also hover your cursor over here, and you see the fast Ethernet FA0/0 link is up now. But still there is no IP address that has been configured on that. So how do you do that? You basically again go to the CLI, and after using interface FA0/0 and no shutdown, then you use a command called IP space address. And by using IP space address, what you need to do, you need to specify the IP address that you want to use, which in our case is 192.168.1.1. And then you give a space and enter the subnet mask as well, which is 255.255.255.0. There you go. So you can also see that it prompted it pointed out the error that you have, that I'm using double IP. That's why the command was not accepted. So by using the upper navigation key, I can go to the last command, and using the left navigation key, I can come at the very starting of this command. You cannot use mouse cursors over here to play with that. You see, if I even click over here, the pointer shows it's over here, but as soon as I type something, it goes back to where it was. So the mouse pointer doesn't work here, and I'm gonna like only the keyboard navigator keys will work. And then I fixed that particular command and I hit enter, and there you go. It didn't give any error. And you can again go back onto the statistic, hover your cursor onto the router, and you can check that the FA0/0 has been configured with 192.168.1.1/24. Make sense? And then the interface is up and everything is running here. Now, if you want to verify the list of interface that you have over here as well from CLI, and not because in real environment, you're not going to have any GUI that will give you the statistics. So what you need to do here, you actually need to use something that you can take an exit from there and come back into the enable mode. And you can use a verification command in this mode that says show IP interface brief. Well, switches all interfaces are up by default. Okay, Rishabh, you need to turn on the router's interface because routers, every interface is into different broadcast domain. So by default, it's off, and it needs like more power consumption. That's why you need to make it like on. But it is like participating into different broadcast domains. So that's why the router's interface or all the interfaces are off, and you need to make them on, and then you can select that which interfaces do you actually want to work with. So when I go into the enable mode, then I can use a command that says show IP interface brief. And as I hit enter, you can also see the same output over here, that these are the list of IP address, like list of interfaces, and the IP address configured on them, and then the status. Okay, so it says up, up, and the others are administratively down. And then you hit enter, and then after that your router configuration is complete. Now we don't need to do anything on the switch yet, so we just need to assign the IP addresses to the PCs that you have so that they can communicate together. So how do you do that? You basically click on the over here onto the PC, then from the PC you can click on desktop section, and then once you click on desktop, then you will get all these options here, and you can click on IP configuration, and then you hit over here the IP addresses that can be 192, then 168, then 1.2, and then you press tab there, and it will automatically get the subnet mask configured. Then you can close this PC, you can go to the next PC, go to desktop, go to IP configuration, and say over here IP address as 192.168.1.3, and press the tab button, and then done. And then you can close the IP or close the computer section, then go to again desktop, IP configuration, and press the IP over here as 192.168.1.4, and then you hit the tab button, and then you can close it. And then if you hover your cursor onto these PCs will also notify you that the IP is configured as 1.2/24. Then on the second PC you have 1.3/24, and you have 1.4/24 on the laptop. So that is how you basically configure a basic topology. And then in order to make sure that the communication between them is working, you can select a message from here. Okay, this is basically something that says add a simple video. So you can click on this message, and then you can like click on the PC from which you want to initiate the communication, and then you can click on the other PC where you actually want to send the traffic, and you hit enter, and there you go, the communication was actually successful. You can verify that over here. Just like that, if you want to select, if you want to send traffic between some other devices, select the cable, select the message again, click on the source, click on the destination, and there you go, successful. PC1 to laptop 0. If you want to send traffic between this PC and the router, you can click the source and destination. There you go, successful. Make sense what I'm talking about? Yeah, perfect. So go ahead, try this simple lab that we actually did. I'll write down the commands that we use. Over here, we on our router commands, we use interface, or we first went into enable, and then we said configure terminal, and then we said interface FA or 0/0, no shutdown, and we said IP address 192.168.1.1 along with the subnet mask. That's all the command, and then we use the verification command that says show IP interface brief. So use this command, build up your topology, and see if it works. Yep. I hope you all are done with the lab. All right, moving on. Next thing, we're gonna explore something that is called as DHCP, and most of you have heard about DHCP, which actually stands for Dynamic Host Configuration Protocol. Cool. And this dynamic host configuration protocol does the work of provisioning IP addresses and other parameter information, be it gateway, be it DNS, or be it some other thing, uh, by using DHCP protocol itself. So what we are going to do now, we are going to place a couple of more end devices to the switch that we are using, and then we are going to configure the IP addressing parameter on those devices, not by using manual configuration, but by using DHCP configuration there. So how do we do that? There are just a couple of more commands that we actually need to add, but I'll again do the entire thing again, okay? Because some of you might have missed the configuration that we have did. So what we're gonna do, I'm gonna restart this particular device. And how do I do it? I can go onto this particular router, and I can go to the enable mode, and then I can say restart. Oh, it's not restart, it's reset. Okay. So when you say reset, oh, okay, it's reload. Yeah. Neither restart nor reset, it's reload. So when you say reload, and then it asks you whether you want to save the configuration that has been modified. So I say no here, I don't want to save the configuration, and I hit enter. It says proceed with reload. I say yes, and then it again starts to decompress the image. And there you go, the device is up again. It asks you, would you like to enter the initial configuration dialog? I'll say no. And now again, what we are going to do now, we are going to add some more devices to it before we configure the router. And over here, I'll place another PC and another laptop. So I select the cable here and then connect it with the same switch that we have. Just a minute, guys. Yeah. So after placing the couple of devices here, I go to you see the interface has again become down here. So we need to turn on the interface configured with the IP address and provision a DHCP configuration there. And how do we do that? We basically go to the enable mode, go to global configure mode by saying configure terminal, and then selecting the interface by saying interface FA0/0 and saying no shutdown. And then you see the interface is coming up. The switches interface, however, takes some time to start. So from red, it has become, I would say, amber or orange, and from orange, in some time, it will become green. So we're going to talk about why this process happens when we will discuss about layer 2 switching, or we will discuss about spanning tree protocol. But yeah, for now you can see that the router's interface has become green now. So after it becomes green, you can go ahead and configure the IP address by saying IP space address 192.168.1.1 and space 255.255.255.0. And then after that, what you need to do is you need to create a DHCP pool. There can be multiple DHCP servers that can be configured on your router because your router has the ability to, I would say, handle multiple networks. So what you're gonna do here, we're gonna create a pool. Let's say the users that we have connected belong to a sales department. So I'll create a pool with the name of sales by saying IP DHCP pool sales. Okay, and you can see that the mode of my config has been changed to DHCP config now, not the interface config. So by doing this, I say IP DHCP pool sales, and then after that, I need to define what network do I want to specify the IP addresses of via this DHCP. So I go into the DHCP pool settings and I then say network space the network ID. So we say 192.168.1.0, which is the network ID of the network that we're using. And then along with that, you need to specify the subnet mask. So we hit enter here. And then after that, I say default hyphen configure, default hyphen router, and then give the IP address of the router that we have. Okay, so we say default hyphen router 192.168.1.1, hit enter. Now what this default hyphen router is going to do is it's going to configure all the other PCs with, so the network command is going to configure the endpoints of the PCs with the IP address and the subnet mask. But along with that, it will also provide default gateway configuration information to these routers. Makes sense? So the PCs will be configured with IP address, subnet mask, and default gateway. And the default gateway over here will be 192.168.1.1 because that's the one that we have specified. So we entered over there, and then we take an exit from that particular thing. And then what we can do, because our PCs already have the DSC, the static IP addresses configured, we can select the PCs that we newly have added, and then we can click here, go to desktop, go to IP configuration again, and then say DHCP. And you can see it's requesting IP address, and then it should get, okay, it failed out, and then we again say DHCP, and there you go. The DHCP request was successful, and it says the IP address has been assigned, which is 192.168.1.6. Then we have 255.255.255.0, and we have default gateway configuration here. Just like that, if I go onto the new laptop and then go to desktop and say IP configuration and DHCP, then you can see that it has received 1.7 along with the other IP parameter. You can even go onto the previous PCs which are already having some IP addresses. And instead of saying static, you can click on DHCP and they'll also get some IP addresses there. There you go. 1.8, then you have 1.9, and you also have 1.10. So you see, this DHCP pool keeps on assigning the IP addresses sequentially to the number of requests that are being actually given. Makes sense? So DHCP internally communicates or works by using different messages. You have D, which stands for, or DHCP works, DORA process. And this DORA stands for, D stands for discover, O stands for offer, R stands for request, and A stands for acknowledgement. So if any particular, I would say, user, or if any particular PC tries to request a DHCP address, then initially the discover message is sent onto the broadcast address. Then after that, the offer message, like once a DHCP server gets that discovery message, then it sends an offer to the user who is requesting that DHCP. And then once the offer is received by the user and it is accepted by the user, then the user gives a request which is actually a DHCP request saying to the server that, hey there, I want to take that address. Please provide that address to me. And then the acknowledgement is given containing all the information. So this is how DORA process actually works for assigning the IP address by using DHCP. Okay. So what you need to do now over here is we're going to work in a way that you need to configure something, you can say a topology for me, which is going to be like this. So you need to take a router, and then you need to take another router. You need to take a couple of switches. Okay, and then you need to also take a couple of PCs over here. And what you're gonna do, you're gonna connect all these devices together. Like this. And the network that you're gonna configure over here is 192.168.10.0/24. And you're gonna configure 192.168.20.0/24 here. And the requirement over here is both the routers should be up and the PCs should receive the IP addresses with the DHCP configured on them, not the statically. So these are the two networks that you need to configure. And then once you do that particular lab, then we're going to go ahead and configure something called static routing. And we will make these two network communicate together by using that. So go ahead, try this particular thing, so the IP config and the DHCP for these topology, and let me know when you're done. Hey there, I hope most of you are done. Okay, I'll show you guys how you need to do this configuration. So you see, we created a topology which was like this. And you actually wanted, or I actually wanted you guys to configure this topology by configuring the IP and DHCP settings. So what we're gonna do, I'll go on to this particular router first, and then inside of this router, I'm gonna go on CLI, and I'm gonna say no here because we don't want this configuration to be done. And then after that, what I'm gonna say, enable, and then configure terminal. Then interface FA0/0, no shutdown, and IP address 192.168.10.1 along with the subnet mask. And then after that, you create a DHCP pool by saying IP DHCP pool, let's say A here. And then we'll give a network ID of 192.168.10.0 along with the subnet mask like this. How there is, okay, yeah, like this. And then we say default hyphen router 192.168.10.1. Make sense? Then after this, what we are going to do, we're going to go on the another router, which is this. And on this router, we're going to configure a network that is 192.168.20. So I'm going to go into the CLI, and then I'm going to say no, enable, configure terminal, and interface FA0/0, no shutdown, IP address 192.168.20.1 along with the subnet mask. And then we say IP DHCP pool B, and then network space 192.168.20.0 along with the subnet mask. And then we say default hyphen router 192.168.20.1. And that's exactly how you come up with the DHCP configuration for both of these networks. Then I can click on each of this PC individually, go on to the desktop section and IP configuration, and click on DHCP. And there you go. The IP is configured from 10. Then over here, the IP is configured from 10.3. And this should be 20.2. There you go, 20.2. And then you'll have 20.3 here. Sounds good. That's exactly how you basically configure it. Now, the requirement over here is the requirement over here is I want you to make something in a way that you want the people from 10 network to communicate with the people from 20's network. So let's assume that a PC is initiating a communication from this PC and then it needs to go on to this PC. So how would the communication happen over here? So in order to do that, you also need to connect both of these routers together, right? And you do that by connecting it with a cable. So you take a cable and then you connect this router with the other router. Let's say this is our R1 and this is our R2. Okay, I'll also name them by going over here, taking an exit, and I'll say host name is R1. And then I'll go on to the other router and say host name is equal to R2. You see that? The IP, the names has been changed. Now what I want is when the PC tries to communicate or when the PC wants to communicate from here to here, then the packet will actually be sent onto the router. Then router needs to decide that it needs to send the traffic to R2. But it will only be able to send the traffic from R1 to R2. Okay, we need to create a subnet here. So we'll create a new network and we'll say this network is 192.168.30.0/24. And let's say we will provide an IP of 30.1 here, and then we will provide an IP address of 30.2 on the other end. Make sense? So for doing that, you need to go into the R1, you need to go into SE2/0 and say no shutdown and provide an IP address of 30.1. And you need to go onto the R2, turn on the interface SE2/0, and then configure an IP address that is 30.3 or 30.2. Sorry. So you go onto the router and then you say interface SE2/0, no shutdown, IP address 192.168.30.1, correct? And then you say 255.255.255.0. And then on the other end, you say interface SE2/0 again, say no shutdown, and IP address 192.168.30.2 and 255.255.255.0. Make sense? Why 30.2? Because you can check the interface over here. You can check the interface over here that we are using. It is 30 dot. It is SE2/0 here, and over here as well. It is SE2/0. So that's why the routers by default uses serial interfaces in order to get connected together. So these are serial interface. You can see if I go into the router and click on the physical, and then if you check that, if I zoom in, you see over here, these are the interfaces that you have. So these interfaces are the fast Ethernet interfaces that you have, which is FA0/0 and FA0/ I would say 1. And these two interfaces are serial 2/0 and serial 3/0. And the other two are basically the fiber interfaces that you have. But we're not using those anymore. Make sense? So we say interface SE2/0 is being used for the communication between both of these routers. And once I configured these IP addresses on both of these interfaces, then you can see the link between them again became green. So if I hover my cursor onto R1, you can check that my FA0/0 is configured with 10.1 and my SE2/0 is configured with 30.1. And if I go on to the R2 and check the same information, you can see that my FA0/0 is 20.1 and SE2/0 is 30.2 there. So when I click on R1 and go to the CLI and try to ping to the R2, does it works? So I can go on this, I can go on to the enable mode and say ping 192.168.30.2 and hit enter. There you go. The exclamatory mark indicates that the communication was successful, and you can see that the success rate is 100% there, which means the ping message was successfully delivered. You get that? So, as of now, if I see, then I have 192.168 at 10.0, then I have 192.168 at 20.0, and I have 192.168 at 30.0. These are the three networks that we have in the topology. Now, as we want to, I would say, implement some static routing. And when we say static routing, what do we mean by it? Is the communication between two different networks needs to be done over here from one network to the other network. So we have 1.0 and we have 2.0 here. Yeah. You connect two different routers by using serial interfaces. So when I'm doing that particular configuration, you can check that from R1. So here's the thing. Every router maintains something called routing table. And routing table actually is the brain of the router, according to which it forwards the traffic. So the only job that the router has got is to forward traffic from one location to other location by using the best route that is possible. And for every route that exists into the topology, your routing table should be updated about that. Otherwise, if the route is not present into your routing table for the destination, then the traffic will not be sent. Okay, yeah, you can call that as V.35 cable as well. If I try to send traffic from PC3 to PC6, then currently the communication will be failed, even though everything is green. When I even if I even try to send traffic from here to here, it will not work. Why is that? Because the router is not aware about the other route that is there. You see, so there are two type of networks that we have. When we consider two type of networks, the first is called as directly connected network, and the other one is called as basically indirectly connected network. Make sense? So, what is directly connected network and what is indirectly connected network? The networks which is actually connected to the router, it's called as directly connected network. Plain English, right? But if you have a network in the topology about which the network actually exists, but it is not connected with your router, it will be called as indirectly connected networks. And I was telling you something about routing table as well, right? So routing table is basically a table where all the information about the networks that the router knows about is maintained. And you can check the routing table of individual routers by going into the enable mode and by using a command called show IP route. When I use this show IP route command, I'm gonna get the list of all the networks that my router currently knows about. You see? So these are different codes. I've used a command that says show IP route, which is used in order to get to know about the routing table of the router. And you can check that these are all the protocols that are supported onto the router. And then you can see the routes as well. So currently my router only knows about 192.168.10.0, and it knows about 192.168.30.0 as well. Make sense? But if I check about R2 and if I run the command called show IP route, so if I check about the information over here that says do show IP route, then you can see that the other router knows about the directly connected network which is 192.168.20.0 and 192.168.30.0. And then after that, if you look at the indirectly connected network, the R1 doesn't know about the other network, which is 20.0, and the R2 doesn't know about the first network, which is 10.0. You can check the routing table of both the routers over here. You can see that the R1 only knows about 10 and 30 network, and the R2 only knows about 20 and 30 network. So you can say that 30 is kind of a common network that you have, that both of them knows about. But R1 doesn't know about 20 and R2 doesn't know about 10. And that's why if I try to send traffic from this PC to this PC, the PC actually checks whether it knows about the source IP and the destination IP that is going to be given into the IP header. Does it know about it into the local routing table? Then the PC finds out that there is no information about the destination network in my local routing table. So what does it do? It considers that destination network for unknown network, and it forwards that all the unknown network traffic to its default gateway, okay, which we have configured over here as 10.1, which is our router. So indirectly the router will receive all that particular traffic over here onto the router. Now the router will check in its routing table whether it knows about the source and whether it knows about the destination, and it checks for this information into the routing table that it maintains. And after getting to know about that, then it will decide that on which of its interface it needs to forward the traffic. And then based on that information, it will forward the traffic ahead. But as of now, you can see that whenever I'm trying to forward traffic from this PC to the other PC, it's getting failed. Why so? Because whenever the traffic is being received by the gateway is checking the routing table and it gets to know that it doesn't know about the destination network, which is 20. So, static routing, when we say we are implementing static routing, it means that we will statically inject a route in our routing table about 20.0, and in R2 we will inject a route about 10.0 in our routing table. Yeah, so over here, when we actually do you understand, guys, the concept of static routing? In static routing, we are going to inject specific route into the routing table of our router, and by considering that route, it will be able to forward the traffic from one location to other location. So how do we do that? Now, as our entire network is configured, because this is the prerequisite, right? Your network should be configured with all the IP addressing schemes, and all the I would say interfaces needs to be up there. Then what we are going to do, we're going to tell about 192.168.20.0 to R1, and 192.168.10.0 about about 10.0 to R2. And how we're going to do that? We will go on to the R1, and we will go on to the configure terminal, and then over here say IP space route space 192.168 dot I would say 20.0. So I will specify the network ID of the indirectly connected network there, and then I will give it a space and then say subnet mask, and then give it a space, and then after that what I'm gonna say is we need to specify something called exit interface. So understand what's exit interface. On this router, when the traffic is going to receive, it doesn't know where the destination is actually situated. Make sense? The only thing that it knows about, that if I want to send traffic to 192.168.20.0, okay, yeah. So when we say that if I would say I want to add the static route, then I want to mention over here after saying IP space route 192.168.20.0 and 255.255.250, I need to mention something called exit interface. Now, when the traffic will take an exit from R1, which interface is it needs to take an exit from? It's SE2/0, because this is the interface that is facing towards R2. where the destination is. So we go over here and we say SE2/0 and then hit enter. And just like that, when I use this particular command, I can again verify my routing table by saying show IP route, and then you can see that there is a new static route that has been added, which says 192.168.20.0. You see this S indicates that it's a static route. Make sense? And just like that, I will go on to the other router, and you can check that there is no static route as of now. But then I'm gonna say IP route 192.168.10.0 along with the subnet mask, and then the exit interface on R2 as well is SA2/0. So over here I say SA2/0 and then take an exit. And then after that, if I show you show IP route, there you go. You have another static route that says 192.168.10.0, right? On the other side, you have 192.168.20.0. And this is how you update the static route information into the routing table of your routers. And now that both of your router are aware about the networks that they're connected with, then I can try sending traffic from this PC to this PC, and it will be failed for first time because of the ARP resolution process that the router does. And then after that, it's gonna make that particular communication successful. So I'll again try to send traffic from here to here, and there you go. Now it's successful. And then if I send traffic from here to here now, first time it's gonna fail, and then it's gonna successful. Make sense? Soumya, yeah, you can give next hop IP address as well, but this concept is not, I would say, recommended anymore. So I'm not gonna discuss about that. I will please suggest you to use the exit interface itself to be specified over there. Yeah, thank you. ARP is basically address resolution protocol about which we're going to discuss. ARP is used in order to figure out the MAC address from a given IP address to get to know about the physical location of that. So the first packet is failed in the simulation for the ARP resolution, but in real time, you will hardly notice that. In real time, all your packets will be delivered quickly over there. Make sense? So this is how the configuration has been done. Okay, cool. Now we're going to look into something, or there is something that you need to do. Is we're going to extend the routing, static routing scenario over here, and we're going to do it by having multiple, I would say, routers here. So let's say I'll bring up a topology which looks like this, and then we have a couple of PCs that are connected here, and we have your connections that are made up with 4 different local area networks. But there's going to be a tweak, or you can say challenge, in this topology. And then what you're going to do is this. Yeah, exactly like that. So the networks that you're going to have is 192.168.1.0/24. Then you have 192.168.2.0/24. And you have 192.168.3.0/24. And 192.168.4.0/24. And then after that, you have 192.168.5.0/24. You have 192.168.6.0/24, and you have 192.168.7.0/24. So how do you configure it? The only challenge that you have here is We can say that if we look at the perspective of R1 and if we look at the perspective of R4, then these are the edge routers, or these are the routers which only has a single exit interface there. Okay, and if you look at the perspective of R2 and perspective of R3, you have multiple exit interfaces. You have SE2/0 facing towards R1, and you have SE3/0 facing towards R3 on R2. And on R3, you have SE2/0 facing towards R2 and SE3/0 facing towards R4. So when you consider adding the indirectly connected networks, how many can you tell me how many directly connected networks does R1 have? Can I say there are just two networks? And same for R4 as well, right? Yeah. But if I look at the perspective of R1, how many indirectly connected networks does R1 have and R4 have? Can I say for R1, 2.0, 3.0, 4.0, 6.0, and 7.0? All these networks are indirectly connected networks for R1. And then for R4, we have, I would say, 1.0, 2.0, 3.0, 5.0, and we have 6.0. So all these networks are basically indirectly connected networks for R1 and R4 respectively. So you will be adding all these indirectly connected networks into R1 and R4's routing table statically. And then if you look at R2, R2 has three directly connected networks, which is 5.0, 6.0, and which is 2.0. But you see, when you will be now 1.0, 3.0, 4.0, and 7.0, all these networks are basically indirectly connected networks for R2. But when you will add a static route for 1.0, then the exit interface will be SE2/0 because that's the direction where the network needs to go through. And if when you will add the information of 3.0, 4.0, and 7.0, then you need to, I would say, use an exit interface of S3/0. Make sense? So exit interface kind of is critical information that you add up into the configuration when you configure static routing. Do you understand what I'm trying to say? Vincent, if you remember something that when we use a command of static routing, you see, over here, you can check the scenario that in this IP route command, we are using exit interface as SE2/0 because that's where we want the traffic to go whenever there's any traffic for the destination of 20.0. In similar cases, if you add the static route on R1 for 2.0 or 3.0 or any network that we have, the only exit interface that R1 has is SE2/0. But if you consider R2, then R2 has different networks situated with different or situated with the reachability of different interfaces. Yeah. It is advisable or it is advised as the best design practices to use next hop IP, to use exit interface in comparison with next hop IP addresses. Okay. So the best design practices say that use next hop like exit interface and not the next hop IP address. So when we actually use it, then what you need to do is while adding the static route for R2 and R3, you need to consider the network that you're gonna add and the exit interface where it can actually be reached for. Okay, so this is one of the, I would say, thing that you need to focus on, and I want you guys to work on it and make sure that you are able to configure. So the task for you in this particular practice is configure all the IP addresses first, then make sure that the Ethernet networks get the IP addresses via DHCP, then connect all the serial networks, okay, with the IP addresses of their network. You can say 5.1, 5.2, 6.1, 6.2, 7.1, 7.2, and then implement static routing. And then after that, each of this particular PC should be able to communicate with each other. Sounds good. So I want you guys to first try this thing. Okay, take your time. Around 20-30 minutes will be required to do this particular practice, and then I'll show you how you can work with it. Sounds good to you all? By this way, you will be able to understand the doubts in your mind and the questions by yourself. And then I'm gonna show you the configuration by myself, and then you all your doubts again will be cleared up. Perfect. Go ahead, try this particular topology and see if it works. I would request you to not extend the last topology because practice is something that we emphasize on. So create a new topology and this will kind of make you better in terms of getting to know about the CLI and so. Go ahead, try this thing and see if you get done with that. Okay, and then I'll show you the lab. Thank you. Yeah, all right, guys. Time's up. So now I will show you how the configuration can actually be done. And in that, we're going to start with a very basic thing, which is about configuring the IPs. So I'm going to go into each router and I'm going to configure the fast Ethernet IP addresses and the serial interfaces that we have here. Sounds good? So this is our going to be R1. I'm going to say no here. Enable conft hostname R1. Then interface FA0/0, no shutdown, IP address 192.168.1.1 along with the subnet mask, and then IP DHCP pool A and network 192.168.1.0 along with the subnet mask and the default gateway configuration. Correct? Then I'm going to take an exit from that mode, switch the interface to SE2/0, say no shutdown there, and IP address 192.168.5.1 here. Yeah, there you go. So after configuring the IP address on SE2/0 as well, then we're gonna move to R2, and we will also ensure that the DHCP config onto the devices are okay. So here we go, and then there we go again. Right? Then I'm gonna go to R2, and on this R2, we're gonna say no, enable configure terminal, then hostname R2, interface FA0/0, no shut, IP address 192.168.2.1 along with the subnet mask, and then IP DHCP pool B, network 192.168.2.0 along with the subnet mask, and then default router 192.168.2.1. That's all. And then we switch the interface to SA2/0, no shutdown, and say IP address 192.168.5.2, right? And then we will change the interface to interface SE3/0, say no shutdown, and IP address 192.168.6.1 along with the subnet mask. Correct? This is the configuration that we are gonna do for R2. Then I'll get the IP address configuration onto the end devices, and we're good. There you go. And then we are going to move next to R3 now. And on the R3, we'll say no here. Enable configure terminal interface FA0/0, no shutdown, IP address 192.168, then 3.1 along with the subnet mask, and then IP DHCP pool C network 192.168.3.0 along with the subnet mask, and the default hyphen router is going to be 192.168.3.1, and take an exit there like that. And then we're gonna switch our interface to SE2/0, configure an IP address over there that is going to be 192.168.6.2 along with the subnet mask, and interface SE3/0 with an IP address of 192.168.7.1 along with the subnet mask, and take an exit. Correct? That's gonna be the configuration IP config for third router, and then we're gonna go and check whether the IP is up or not, and boom, and there as well. Yeah, we're good. And then we go on to the last router and say no, enable configure terminal, say interface FA 0/0, no shutdown, IP address 192.168 4.1 along with the subnet mask. And then you say IP DHCP pool D network 192.168.4.0 along with the subnet mask, and default hyphen router 192.168.4.1 along with the no subnet mask required there. And then we take an exit and configure the SE2/0 with the IP address of 192.168.7.2 along with the subnet mask. There you go. So you can check that the IP is up and all the interfaces are green. And we'll go on to the PC of last network and should expect an IP address of 4.0 subnet. There you go. Desktop IP configuration and DHCP. Cool. If I verify that by hovering the cursor onto each router, you can see that on R1, FA0/0 is 1.1, SE2/0 is 5.2, 5.1. On the next router, we have 2.1, 5.2, 6.1. Then we have 3.1, 6.2, and 7.1. And then on the last one, we should have 4.1 and 7.2. There we go. All good. Now we're going to add the static routes. So on R1, as I already have told you, we need to add 5 different routes, right? And everyone would be facing towards SE2/0. And the routes are going to be 2.0, 3.0, 4.0. Then we're going to have 6.0 and 7.0. So going on R1, and I'm going to say IP space route 192.168.2.0 along with the subnet mask and SE2/0. Boom. And we have 3.0, we have 4.0, we have 6.0, and we have 7.0. And take an exit, and there you go. So I can verify my routing table like this, and you see 1, 2, 3, 4, 5, 6, 7. All the routes are there into the routing table. 2 routes are directly connected, and rest of them are static routes. Then we're gonna move on to the R2, and in the R2, we're gonna add 1.0 facing towards 2/0 and 3, 4, and 7 facing towards 3/0. So I'm gonna say configure terminal IP route 192.168.1.0 255.255.255.0 SE2/0, and then I'm gonna say 192.168.3.0 255.255.255.0 SE3/0, and then 4.0 and 7.0, right? And then we can check the routing table by saying show IP route, and here you go, 1, 2, 3, 4, 5, 6, 7. And then if I go and verify or do the configuration on 3, then of course 1, 2, and 5 are going to be via 2/0, and just 4 is going to be via 3/0. So here we go, IP route 192.168.1.0, 255.255.255.0, SE2/0. Then you're gonna have 2 with the same and 5 with the same, and you're gonna change it to 3 for 7.0 network. Make sense? And then I can say show IP route, and there we go, 1 2 3. Oh, there is no 4. There is no 4 because the last route that we added, it's the wrong information. So we need to change this particular route. We didn't need to add we didn't need to add 7.0 network, and instead of that we needed to add 4.0. So I'll remove that particular route by saying no IP route 192.168.7.0 and SE3/0, and then I'm gonna add 192.168.4.0 and SE3/0. There you go, and say exit show IP route. There you go, 1 2 3 4 5 6 7. And then on the last route we're gonna add everything by saying IP route 192.168.1.0 F255.255.250 SE2/0. Then you're gonna add the same for 2, the same for 3, the same for 5, and the same for 6. And then you can take an exit and say show IP route. You see 1 2 3 4 5 6 7. Now when you have such kind of scenario, then you can see all our routing has been implemented. And then if you try sending traffic now that all our network is segregated and configured, I can send traffic from here to here. The first packet is going to fail. If you double click on this particular packet, it's going to resend that. So double click. There you go, successful. If I send from here to here, first packet failed, double click, successful. Then from here to here, first packet failed, double click, successful. From first to last, successful. Do you understand that? Yeah, this is for learning purposes. We're not going to implement bus topology in the production environment, of course not. But yeah, I need to take such references so that you'll be able to compare it with the star topology or some other type of topology there. So do you understand, guys, how did we work through this? Perfect. Okay, so this was actually something that we had to look into. In today's session, we saw how basic configuration can actually be done. We got, I would say, introduced with the Cisco's CLI, command line interface. Then we also, yeah, you can get the PDU without clicking on it just by using P. So you see, the shortcut key for that is P. So when I actually say P, it gets selected. Perfect. In tomorrow's session, we are going to talk more about how default routing works and how different scenarios actually works over there. Okay, in the same topology itself, and we will talk about some of the limitations of static routing and see how load balancing and all those other things work. So there are two different types of static routing which we have to explore now: default routing and floating static routing. We're going to talk about that in tomorrow's session. I hope you enjoyed today's session. Do practice a bit on this particular concept and make yourself more familiar with the CLI.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Care of yourself. I hope you enjoyed the session. You're gonna get the recording soon as it gets uploaded onto the drive. And yeah, practice a lot. Thank you so much for joining us.